Imagine standing alone in the middle of a vast desert, under an endless night sky. You look up, billions of stars shimmer above you, each one, perhaps, with planets of its own. Some of those planets might look like Earth, some might have oceans, skies, life. And yet, in the silence, there's nothing. No signals, no ships, no distant voices, just quiet. This is the paradox that keeps scientists awake at night. It's called the Fermi paradox, a simple question that asks, if the universe is so big, where is everybody? With trillions of stars in the observable universe, many of them older than our sun, and countless Earth-like planets orbiting them, why haven't we seen any sign of intelligent life? Why hasn't anyone said hello? One possibility is that intelligent civilizations are incredibly rare, that we are the exception, not the rule. Another, more chilling thought, maybe civilizations rise only to destroy themselves before they ever make it to the stars. Or maybe they're out there, watching, waiting, listening, in the dark. It's also possible that we simply don't know how to listen, that their form of communication is beyond anything we can detect, or that they exist in ways we can't even comprehend. Some thinkers suggest we may be living inside a kind of cosmic zoo, observed but deliberately isolated, kept in the dark until we're ready, and still others wonder if there's no one else out there at all, that in this infinite cosmic sea we might truly be alone. Take a moment to reflect on that, the sound of silence echoing across the stars. And now, as we float in the stillness of space, let's dive into another mystery, not about the stars above, but the thoughts within. Close your eyes for a moment and try to notice the next thought that enters your mind. Where did it come from? Did you choose it? Or did it simply appear? This brings us to one of the most unsettling questions in both neuroscience and philosophy. Do we truly have free will? Or is it all an illusion? You may feel like you're in control, choosing what to say, what to feel, even when to sleep. But modern science has begun to chip away at that comforting belief. In laboratory experiments, neuroscientists have discovered something strange. When subjects are asked to press a button at any moment they choose, their brains decide to press the button, before they're consciously aware of having made a decision. In other words, your brain acts, and only afterward do you feel like you decided. It's as if your consciousness is not the driver, but the passenger. Now pause, and imagine what this means. If your decisions arise from unconscious brain processes shaped by your genetics, your environment, your experiences, then are you really choosing anything at all? From the clothes you wear, to the career you chose, to the person you fell in love with. Was it choice? Or was it the perfect storm of neurons, hormones, and history playing itself out? Philosophers have wrestled with this idea for centuries. Some say free will is necessary for morality and justice. Others argue that understanding its illusion might lead us to more compassion, less judgment, and a deeper understanding of what it means to be human. Still, if we are not the authors of our actions, then who, or what, is? Take a moment now to let that settle. Let it drift across your mind like a breeze across still water. And as the question of choice dissolves into the quiet of the night, let's turn to something even stranger. The idea that reality itself might only exist when someone is watching. Let's drift deeper now, beyond the mind, beyond the stars, into the fabric of reality itself. At the smallest scales of the universe, in the strange world of quantum mechanics, things don't behave the way they do up here, in everyday life. Particles don't seem to be particles. They exist not as solid objects, but as clouds of possibility. They can be here, or there, or both. That is, until someone looks. You see, in the quantum world, just the act of observation changes everything. This is known as the quantum observer problem. In experiments like the famous double-slit test, particles such as electrons behave like waves, rippling through space, interfering with themselves, until they're measured. And then, suddenly, they behave like tiny solid dots, as if reality was waiting for someone to notice. This raises a disturbing question. Does consciousness play a role in creating reality? Is the world incomplete without an observer? Some scientists suggest that it's not the observer, but the act of measurement, an interaction, a collision, a change, that forces the universe to decide what is real. But others wonder if awareness itself is part of the equation. If no one is watching the moon, is it still there? Take a moment now to sit with that thought. Right now, your eyes are closed, but the world continues outside your window. Or does it? Is reality out there? Or is it in here, inside your mind? And if the universe needs a witness, what does that make you? A traveler, an observer, a creator? Let those questions drift into the silence. Let them hover, unanswered, like particles in a quantum cloud. And now, let's pull back from the edge of perception and step into a mystery even stranger than observation. What if everything you've ever experienced is a simulation? Close your eyes and imagine this entire world, every sound, every smell, every moment, is part of a high-resolution illusion. What if your memories, your thoughts, even your dreams, were all happening inside a machine? This is the unsettling idea behind the simulation hypothesis, the theory that our entire reality could be a highly advanced simulation. The concept may sound like science fiction, but it's taken seriously by philosophers, scientists, and even Silicon Valley thinkers. People like Elon Musk and physicist Nick Bostrom have asked, if technology keeps advancing, wouldn't future civilizations be capable of simulating entire worlds? And if they can, how do we know we're not already inside one? Think of how far our simulations have come, from Pong to lifelike video games, to artificial intelligence, to virtual reality headsets. If future beings could simulate consciousness, why wouldn't they? And more importantly, what would distinguish a simulated mind from a real one? It's possible that the laws of physics we take for granted, gravity, time, space, are simply the rules of the program. That stars are code, that your memories are data, that every breeze, every heartbeat, every whispered word is rendered in real time. Some researchers believe there could be clues, mathematical patterns in the fabric of reality, like pixels in a screen or glitches in the code. Others argue that it doesn't matter, that even if life is a simulation, our feelings, our choices, our love are still real. That consciousness, no matter where it lives, still matters. So take a breath, in and out. Let the idea float for a moment. You might be living in a dream, but the dream still feels like home. Now, let the digital haze fade into the background as we drift toward the very beginning of everything, a mystery that predates time itself. Now, shift your attention inward, not to your breath or your heartbeat, but to the part of you that's aware of those things. Keep going, further and further back until all of existence collapses into a single point, a place of infinite density and zero size. This is what physicists call a singularity, the moment before the Big Bang, the birth of space, of time, of everything. But here's the question, what came before that? The honest answer is, no one knows. In fact, the question itself might not even make sense, because before the Big Bang, there may not have been a before at all. Time, as we understand it, began with that explosion, as if the ticking of the cosmic clock was switched on in a single blinding instant. But theories exist. Some suggest the universe is part of a cycle, endless expansions and contractions, like the inhale and exhale of a cosmic breath. Others imagine a multiverse, countless universes, bubbling into being, each with different laws of physics, each unaware of the others. Some physicists even propose that the Big Bang wasn't a beginning, but a transition, a phase shift in a deeper, timeless reality we cannot yet comprehend. And then there's the most humbling possibility of all, that the question has no answer, because the human mind wasn't built to understand it. Still, we try, because something came from nothing, because we are made of stardust from an event so ancient we can only hear its echo. Take a breath. You're part of that echo, a fragment of something eternal, contemplating its own origin. Now let's leave the birth of time behind and step into time itself to ask a question we all feel but rarely understand. Why does time only move in one direction? Close your eyes and feel the passage of time. A moment just passed, and now it's gone. You can remember the past, but the future, it hasn't happened yet. But why? This is the mystery known as the arrow of time, the idea that time flows in only one direction, forward, from cause to effect, from birth to death, from now to then. But strangely, the fundamental laws of physics don't actually require this. On paper, they work just as well in reverse. A broken glass could reassemble, smoke could return to a match, a life could run backward. And yet, in the real world, we never see that happen. So, what gives time its direction? Many scientists believe the answer lies in entropy, a measure of disorder in a system. According to the second law of thermodynamics, entropy always increases. Things tend to fall apart, not come together. Order becomes chaos. Heat spreads, memories fade. The early universe, right after the Big Bang, was in a state of astonishing order, low entropy. And ever since then, entropy has been rising. Time, perhaps, is simply the direction in which disorder grows. But that leaves us with a deeper mystery. Why did the universe begin in such a low entropy state to begin with? Why did it begin with order? And why? Do we experience time as a one-way street when physics tells us it could just as easily run both ways? Is time a river, or an illusion, or just the way our brains make sense of change? Take a breath and let time slow down, not rushing forward, just gently unfolding, one moment at a time. And as this moment passes, let's turn inward. Because if time flows like a river, what is it that stands on the shore and watches it go by? Shift your attention inward, not to your breath or your heartbeat, but to the part of you that's aware of those things. What is that? What is consciousness? It's the most familiar thing you've ever known, and yet the most mysterious. You're not just a collection of organs and neurons. You're aware, you experience, you feel. But how? This is what philosophers and scientists call the hard problem of consciousness. It's not hard because it's complicated. It's hard because we don't even know where to begin. We can explain the brain, we can map its structures, we can measure electrical impulses and blood flow. We can even see patterns light up when you think or feel or dream. But we still can't explain why those patterns are accompanied by experience, by being. Why does a brain, made of the same atoms as a rock or a cloud, give rise to something as rich and personal as a first-person point of view? Why does pain feel like pain? Why does red look like red? Why do you know what it's like to be you? Some theories say consciousness is an illusion, just a trick of the brain. Others suggest it's a fundamental part of the universe, like space, time, or gravity, not created by the brain, but filtered through it. And then, there are those who believe consciousness may be everywhere, in varying degrees, a tree, a cat, a planet, maybe even a particle. But no one knows for sure. We can study the brain, but we can't step outside our own minds to observe consciousness directly. You are both the subject and the experiment. So take a moment and rest in that awareness. Not your thoughts, but the you behind the thoughts. The quiet watcher, the still center, the mystery at the heart of everything. And now, as we sit with this enigma, let's consider something even stranger. What if your consciousness is just one of many, in an infinite sea of simulated minds? Let your mind drift into the deep quiet of space, past galaxies, past stars, into the vast cold void. Now imagine a single brain, floating alone, fully formed, surrounded by darkness, no body, no world, no history, just a brain, pulsing with thoughts. This is the concept of a Boltzmann brain, one of the strangest ideas in modern physics and cosmology. Named after physicist Ludwig Boltzmann, it's based on the idea that in an infinite universe, anything that can happen eventually will. And that includes a random fluctuation, a sudden spontaneous arrangement of particles that creates a fully conscious brain with false memories, false senses, and a complete illusion of reality. According to some interpretations of entropy and thermodynamics, it might actually be more likely for a single brain to randomly appear in the void than for an entire structured universe like ours to form. which leads to a disturbing question. What if you are that brain? What if everything you remember, your childhood, your family, this moment right now, is simply part of a temporary hallucination arising from quantum randomness? A thought bubble, in the silence of eternity. Of course, most scientists believe this is just a philosophical paradox, a sign that our current models need adjusting, that something about our understanding of probability or entropy must be missing. But the thought lingers, because if reality can be faked, how would you know? If your senses can be deceived, if your memories can be manufactured, if logic itself can arise from chaos, then what does it really mean to be real? Take a breath and let that question gently float through your mind. No need to answer, just observe it. Because next, we'll return to the realm of experiment, to one of the most famous demonstrations in quantum physics. A simple setup, with a profoundly unsettling message, that even the act of watching can change the world. Now, imagine a simple experiment. Just a board, with two thin slits cut into it, and a stream of tiny particles, electrons, being fired toward the board one by one. You'd expect to see two lines appear behind it, matching the two slits. But that's not what happens. Instead, the electrons form a pattern, not of two lines, but of many. A ripple, a wave, as if each electron isn't a particle at all, but a wave of possibility, passing through both slits at once, interfering with itself. It's called the double-slit experiment, and it changed physics forever. Because when scientists try to observe which slit the electron goes through, everything changes. The interference pattern disappears. The electron behaves like a solid particle again, as if it knows it's being watched, as if reality itself shifts when you try to measure it. Let that sink in. When unobserved, the universe plays by strange, fluid rules, probabilities, wave functions, superpositions. But the moment you look, reality collapses into something solid. So, what is it about observing that changes what is? Does the universe contain infinite possibilities until we choose to see just one? Is it awareness, or interaction, or something we don't yet have words for? And if observation changes reality at the quantum level, what about at higher levels? Does attention shape the world more than we think? Take a breath, in and out. Now imagine this. The act of watching the universe might also be the act of shaping it. And in the next segment, we return to the stars, to a mystery left behind after the Big Bang. Not a particle, not a force, but the absence of something we expected to find. At the moment of the Big Bang, the universe was born in a flash of unimaginable energy. Matter exploded into being. So did its twin, antimatter. For every particle of matter, an equal and opposite antiparticle should have formed. They are like mirror reflections. A proton and its opposite, the antiproton. An electron and its mirror, the positron. And when matter and antimatter meet, they annihilate each other in a burst of pure energy, a cosmic reset. So if they were created in equal amounts, if the universe was truly symmetrical in its beginning, then here's the question: why are we here? Why is there matter left at all? Why does anything exist? Stars, planets, life, instead of just emptiness? This is the puzzle of the missing antimatter. Somewhere, something broke the balance. A tiny asymmetry, so small it's barely detectable, tipped the scales just enough for matter to survive. But no one knows what caused it. Some physicists suggest there were tiny differences in the way matter and antimatter decayed in the early universe. Others propose that mysterious particles or unknown forces violated the symmetry of nature itself. There are theories, equations, experiments underway. But still, the antimatter we expect to find is missing, and the truth remains hidden somewhere between symmetry and survival. So tonight, as you breathe beneath a sky filled with stars, remember this: everything you are, your body, your thoughts, this moment, exists because of an ancient imbalance, a cosmic tipping point that spared matter from annihilation. Take a breath and let the silence of space settle into you, because next we explore a different kind of mystery. Not about what's missing, but about what we cannot see at all. Something invisible, something that shapes galaxies, and bends light. Now, imagine looking up at a galaxy, a swirling sea of stars, dust, and light spinning slowly in the cosmic dark. But something's off. The stars are moving too fast, as if being pulled by something we can't see. That something is called dark matter. We don't know what it is. We've never seen it. We've never touched it. And yet, it's everywhere. Scientists believe dark matter makes up about 85% of all matter in the universe. And yet, it doesn't emit light, or reflect it, or absorb it. It's invisible, undetectable by traditional means. But it has gravity. And that gravity shapes everything. Without dark matter, galaxies would fly apart, stars would drift aimlessly, the cosmic web, the structure of the universe itself would collapse. So we know it's there, but we don't know what it is. Some think it could be a type of undiscovered particle, something beyond the standard model of physics. Others propose it may not be matter at all, but a flaw in our understanding of gravity. There are theories, experiments buried deep underground, satellites scanning the heavens. But so far, no answers, just a shadow that touches everything but hides from sight. Take a moment now to reflect on what surrounds you. The chair you sit in, the room you're in, the earth beneath your feet. All of it floats in an ocean of invisible mass that may never reveal itself. And yet, it holds everything together. Now, if dark matter is the hidden hand behind structure, what about the force that tears it all apart? Look out at the universe, at the galaxies drifting through the cosmic void. Now imagine them moving farther and farther apart, not slowly, but accelerating. This is one of the most astonishing discoveries in modern science. The universe isn't just expanding, it's expanding faster over time, and no one knows why. To explain it, scientists gave the phenomenon a name: dark energy. We don't know what it is, we don't know where it comes from, but we believe it makes up about 70% of everything in existence. Think about that. Most of the universe, nearly 3/4 of it, is something we cannot see, cannot touch, and cannot fully comprehend. Dark energy is the invisible force pushing space apart. It stretches the fabric of the cosmos itself. But what is it? Some theories say it's a property of space, a kind of vacuum energy that builds as the universe grows. Others suggest it's a new kind of field, something deeper than gravity, woven into the geometry of the universe. And some believe it may point to something far more radical, a flaw in our understanding of reality itself. What if gravity behaves differently on the largest scales? What if space and time are not what we think they are? If dark energy continues to accelerate the universe, it could lead to one of many possible endings. The Big Freeze, where everything grows cold and dark as galaxies drift beyond one another's reach. Or the Big Rip, where the force becomes so strong it tears apart galaxies, then stars, then atoms, until even space itself is undone. But for now, we only feel its presence as a quiet, relentless pull, an unseen breath guiding the universe toward its unknown fate. Take a breath yourself, and let that silence wash over you. Because next, we'll turn from invisible energy to something equally elusive, something infinite and yet strangely familiar. A number without end, an idea that breaks the boundaries of logic. Now, let your mind stretch outward, beyond the room you're in, beyond the stars you see, beyond all numbers you can imagine. Keep going, because now we've entered the realm of infinity. Infinity is not just a big number, it's not even the biggest number, it's something altogether different. A concept that lives at the edge of understanding. In mathematics, infinity often seems simple at first. We say numbers go on forever, 1, 2, 3, and on. But the deeper you go, the stranger it becomes. There isn't just one kind of infinity. There are many. In fact, some infinities are larger than others. The mathematician Georg Cantor shocked the world when he proved that the infinity of real numbers is bigger than the infinity of whole numbers. Both are endless, and yet one contains more than the other. It sounds impossible. It feels impossible. And yet mathematically, it's true. This leads to questions that defy ordinary thought. What is half of infinity? What happens when you subtract infinity from infinity? can something truly endless ever be measured or understood? Infinity appears in physics too. In black holes, in the singularity before the Big Bang, in equations that break down when pushed too far. And yet, we use it. We rely on it. We live in a universe that may be infinite in size, or age, or complexity. But here's the strangest part. You can never actually reach infinity. You can only approach it, forever getting closer, never arriving, just like time, just like thought, just like the questions we're asking now. So take a breath, feel the endlessness not as something overwhelming, but as something freeing. A space so vast there's room for every idea you've ever had, and every mystery yet to be solved. And now, as infinity stretches behind us, we return to something smaller, something constant, something that builds the laws of physics themselves. But what if those constants aren't constant at all? The universe, for all its mystery and chaos, seems to run on rules. Precise ones, repeatable, predictable. The speed of light, the gravitational constant, the charge of an electron, Planck's constant. These are the numbers that make reality possible. They don't just describe the universe, they define it. Without them, atoms wouldn't hold together, stars wouldn't shine, life couldn't exist. And so we call them constants of nature, unchanging, universal, fixed. But here's the question, what if they're not? What if the very numbers that form the scaffolding of our reality are shifting, however slightly, across space or time? Some scientists have explored this idea, searching for tiny variations in the strength of gravity, or the fine structure constant that governs how light and matter interact. If they find a change, even in the tiniest decimal, it could rewrite our understanding of the cosmos. Because if these constants can change, then the laws of physics aren't really laws. They're local rules, temporary agreements. And that means somewhere out there, in the deep, unreachable corners of the universe, reality itself could be built on different math, different chemistry, different possibilities. A universe where stars burn cold or collapse instantly. Where life, if it exists at all, must obey a logic we may never understand. But here's the truly strange part. Even within our own universe, there may be slow, silent shifts happening right now. Too subtle to detect, too vast to measure. And we'd never know it. Because we too are made of those rules. If the numbers changed, so would we. Take a breath. In this moment, everything holds together. Gravity pulls, light travels. Reality for now remains steady, but drift gently into the thought. That change may come not from outside the universe, but from its very core. And now we'll turn to another imbalance. One hidden not in what exists, but in what's missing. A mystery left over from creation, still waiting to be explained. In the earliest moments of the universe, everything was a perfect balance. Matter and antimatter, energy and space, symmetry, was everywhere. And then, something broke, because when matter and antimatter meet, they cancel each other out, disappearing in a flash of pure energy. So if they were created in equal amounts, as we believe they were during the Big Bang, they should have annihilated each other completely. But they didn't. Somehow, a tiny fraction of matter was left over, just enough to build every galaxy, every star, every atom in your body. This imbalance is known as the baryon asymmetry problem. Baryons are particles like protons and neutrons, the building blocks of matter. And somehow, they came to outnumber their antimatter counterparts by the smallest of margins. Roughly one extra particle of matter for every billion that vanished in annihilation. But that 1 in a billion was enough to make everything. No one knows why it happened. Some theories suggest unknown particles or forces acted in the early universe, tilting the scale in matter's favor. Others point to violations of certain symmetries, CP violation or time reversal asymmetry, hints of hidden physics beyond our current understanding. But the truth remains just out of reach. A cosmic accident, or a built-in feature of the universe. Was this imbalance random or necessary? And if it had tipped even slightly the other way, we wouldn't be here to ask the question. So take a moment to feel that fragility. the improbable balance that made your existence possible. One extra particle in a sea of vanished light. Now, as we drift from the matter we know into the entanglement of the unknown, let's explore a phenomenon so strange Einstein himself called it spooky, a link that defies space and possibly time. Imagine two particles, born together in the same moment, twins, linked by a mysterious bond. Now send them drifting in opposite directions. One goes left, the other goes right, separated by vast distance. Then you measure one. Instantly, as if connected by an invisible thread, the other particle responds. Not a second later, not after a signal travels through space, but instantly. This is quantum entanglement, one of the most baffling phenomena in all of physics. Einstein called it spooky action at a distance, because somehow entangled particles seem to share information faster than the speed of light, as if space doesn't matter. It breaks our sense of cause and effect. It defies our understanding of time, and yet it's real. We've tested it, repeatedly, and it works. No hidden wires, no trick. Two particles, light years apart, can behave like one system. But what does it mean? Is there a deeper level of reality we can't see? Are all things secretly connected? Is the universe less like a machine and more like a single, indivisible whole? Some physicists think entanglement might be the foundation of reality itself, a kind of cosmic web linking everything. And others wonder if consciousness might somehow play a role in how it unfolds. Take a breath. Let the thought pass through you like a wave of possibility. You are here, now. But maybe you're connected to everything else in ways you cannot yet perceive. And as we float in that possibility, let's peek into a box. A very famous box, with a cat inside, who may be both alive and dead at the same time. Picture a box. Quiet, closed, undisturbed. Inside it, a cat. Alongside it, a small amount of radioactive material, a Geiger counter, a vial of poison, and a trigger mechanism. If the radioactive atom decays, the poison is released. If it doesn't, the cat lives. Now here's the twist. Until you open the box, quantum theory tells us that the atom is in a state of superposition, both decayed and not decayed, which means the cat is both dead and alive at the same time. This is Schrödinger's cat, a thought experiment proposed by physicist Erwin Schrödinger in 1935 to highlight the strange implications of quantum mechanics. Of course, no real cat is both alive and dead. But in the quantum world, particles don't have definite states until they're observed. They exist in a cloud of probabilities, wave functions, possibilities that collapse into certainty only when measured. So what collapses the wave? Is it the act of observation, the presence of consciousness, or something deeper we haven't yet discovered? Does the cat become one thing or the other only when we look? And if so, what does that say about everything else? Is reality unfinished until we experience it? Are we the observers completing the picture? Or is the picture always whole, and our minds are just late to the scene? Take a quiet breath. Feel the uncertainty, not as fear, but as openness, possibility, potential. In this moment, you are both certain and fluid, a thought in motion, waiting to become. And now we drift from imaginary boxes into the hidden world of living ones. From quantum paradoxes to the question of whether plants might possess a kind of awareness of their own. The universe is old, unimaginably old, and vast beyond comprehension. Billions of stars, trillions of planets, endless possibilities for life. And yet, silence. No signals, no visitors, no great galactic civilizations filling the sky. Why? This is the Fermi paradox, but the possible answer to it is even more haunting. It's called the Great Filter. The idea is simple and terrifying. Somewhere along the path from lifeless rock to spacefaring civilization, there is a barrier, a wall, a filter that most life never passes through. Maybe life itself is incredibly rare. Maybe the jump from single cells to complex organisms is almost impossible. Or maybe civilizations tend to destroy themselves through war, technology, or environmental collapse before they ever reach the stars. Here's the eerie part. We don't know if the filter is behind us or ahead of us. If it's behind us, we may be rare, a miracle, survivors of the filter. But if it's ahead of us, it means every advanced civilization eventually hits a wall. And so might we. Artificial intelligence, nuclear war, ecological collapse, technologies we can't yet imagine. If this is the case, then the silence we hear in the universe isn't absence. It's aftermath, ghosts of civilizations that didn't make it. But there's another possibility. Maybe the filter isn't real. Maybe others are out there, watching, waiting, choosing not to speak. Or maybe we are the first spark of intelligence in a quiet, newborn universe. Take a breath. Feel that smallness and the strange, sacred weight of it. Whether we are rare, or doomed, or just beginning, we are asking the question. And now, as we drift further, let's follow the silence to the ultimate stillness. A future not of destruction, but of fading. A slow, cold ending where everything stops moving. Now, imagine the far future. Not 10 years, not 1,000, not even 1 billion, but trillions of years from now, when the stars have burned out, when galaxies no longer shine. What happens then? This is the idea of the heat death of the universe, one of the most widely accepted theories about how everything ends. It doesn't come with a bang, but with a slow, quiet fading. Right now, stars burn with energy, galaxies are alive with light, planets, heat, movement, gravity, all powered by differences in temperature, by entropy flowing from order to disorder. But eventually every star will die. Black holes will evaporate, matter will decay, and all usable energy will be spent. The universe won't be destroyed, it won't collapse, it will simply coast, cold, silent, still, no heat, no life, no motion, just a uniform, featureless sea of near-zero energy. This is the final equilibrium, the end state of thermodynamics. And yet, there's something peaceful about it. A long exhale after eons of creation, destruction, and becoming. The universe falling asleep. Some theorists imagine tiny fluctuations still bubbling in that stillness, perhaps sparking new universes, new beginnings, new cycles. But from where we stand now, it's unknowable. The heat death reminds us that even the grandest systems we know run down eventually. That time stretches not only behind us, but far ahead. And one day, everything we've ever known will be gone. Take a slow breath. Let that thought settle. Not in fear, but in stillness. Because in the face of cosmic endings, there is quiet, there is awe, and there is the miracle of now. Next, we'll leave time's cold horizon and turn inward once again, to a riddle that bends minds and rewrites logic. Can we travel through time? Close your eyes and imagine stepping out of the present, not into another room, but into another time. Backwards, to a memory, a moment, a history, or forward, to something that hasn't happened yet. This is the dream and dilemma of time travel. We move through time constantly, 1 second per second. Always forward, but could we move faster, slower, backward? Physics doesn't forbid it. In fact, time is already relative. According to Einstein's theory of relativity, time passes differently depending on your speed and your position in gravity. The faster you move, especially near the speed of light, the slower time flows for you compared to someone standing still. This has been tested. Clocks flown on planes tick more slowly. Astronauts age just a little less than the people they left behind. So, time travel into the future is not only possible, it's already happening. But what about the past? Here, things get complicated. Some theoretical models, like closed time-like curves, suggest it might be possible to loop back to a previous point in time under extreme conditions. Massive rotating black holes, cosmic strings, exotic matter with negative energy. But all of these exist more in equations than in nature. And then there are the paradoxes. What happens if you go back and prevent your own birth? Could reality allow a contradiction like that? Some theories resolve this with the idea of branching timelines. parallel universes that split off with every choice, every change. Others say time may be like a river. You can flow with it, but you can't swim upstream. And yet, if time is just another dimension, like space, then maybe the past is still there, unfolding, waiting. Take a breath. You are here, in this moment, but maybe every moment exists all at once. Perhaps time isn't a line, but a landscape, and we're simply passing through it. Next, we step away from time and into the mirror to explore something even more elusive than physical dimensions: your mind. You've heard the idea before, that watching something changes it. In quantum physics, this is known as the observer effect, where particles behave differently depending on whether they're being observed. But what if something similar happens inside you? What if your very act of noticing a thought, a feeling, or a behavior changes its nature? This is the observer effect in human psychology, a subtle yet profound phenomenon that shows up in therapy, neuroscience, and self-awareness. When you observe your thoughts without judgment, they begin to shift. When you become aware of your habits, your language, your reactions, you start to rewire them. In scientific studies, participants change their behavior simply because they know they're being watched. In classrooms, in workplaces, even in the privacy of self-reflection. It's as if the mind isn't just a stream flowing through consciousness, but something that responds to the attention we give it. Like quantum particles, our emotions, beliefs, and patterns don't always have fixed shapes. They exist in a kind of psychological superposition until we choose to look. And then they collapse into clarity. This is the power of awareness. You don't have to force change. You only need to observe it, to sit with it, to witness it, to allow it to unfold, right now. As you lie here, still and calm, you are the observer, the quiet witness beneath all the noise, the watcher of your own mind. Take a breath. Let that role settle into you. You don't have to fix anything. You don't have to do anything. Just notice. And now, as you rest in that stillness, we shift from observation to logic itself, to a strange mathematical puzzle that suggests there are truths we'll never be able to prove. Now, imagine a system, a perfect system, one that follows strict rules, precise, logical, orderly. A mathematical universe. It seems complete, self-contained, fully knowable. But in 1931, a young mathematician named Kurt Gödel shattered that dream. He showed that even the most carefully built system of logic and mathematics would always contain truths that could not be proven within the system itself. This is Gödel's incompleteness theorem. And it changed everything. What it means, simply, is that no matter how perfect a structure of logic you build, no matter how many axioms, rules, or truths you define, there will always be statements that are true, but unprovable. Always a question that can't be answered from within the frame. It's like trying to read the label from inside the jar, or asking a sentence if it can prove itself to be meaningful. Gödel's discovery shook the foundations of mathematics and logic. It told us there are limits to certainty. That reason, no matter how pure, has boundaries. But instead of despair, it offers wonder, because it means there's always something beyond. Always more to reach for. Always a mystery that lies just outside the spotlight of understanding. Even the most brilliant minds will always have unanswered questions. And that's okay. Take a breath. Let go of the need to know everything. Let go of the need for perfect answers. There is beauty in limits, and peace in accepting that some truths simply are. Now, as we float through this quiet maze of logic and mystery, we turn to a strange idea in physics and information theory. One that asks, can anything truly be lost forever? Imagine you write a sentence on a piece of paper. Then you burn it. The paper turns to ash, the words vanish into smoke. Gone. Forever. Or are they? In physics, information isn't just words or data, it's the fundamental blueprint of what something is. Its arrangement, its state, its unique signature in the universe. And for a long time, scientists believed that when something was destroyed, burned, crushed, erased, its information vanished too. But quantum mechanics has a different view. According to its laws, information can't be destroyed. It can be transformed, scrambled, hidden, but never truly lost. This idea became the center of one of the greatest puzzles in modern physics, the black hole information paradox. Black holes, as we understand them, pull in everything, light, matter, energy, and crush it into a singularity, a place where the known laws of physics break down. For decades, it was thought that anything entering a black hole was lost forever, not just physically, but informationally. And that violates the rules. So scientists began to wonder, where does the information go? Is it stored on the surface of the black hole, as Stephen Hawking once suggested? Is it encoded in the radiation they emit in ways we don't yet understand? Or is our entire understanding of space, time, and memory missing something essential? This question goes far beyond physics. Because if information is never destroyed, then everything that has ever happened still exists in some form. Your memories, your thoughts, every breath. Not gone, just scattered. Take a moment, let that idea settle. Nothing truly disappears. Everything leaves a trace, even you. Now, as we move from what is remembered to what is felt, we descend into the realm of the body and the strange illusions it can create when something is lost, but still there. Imagine losing a part of your body, an arm, a leg, a hand, gone completely. And yet, you still feel it. Tingling, itching, sometimes pain. This is the phenomenon of phantom limbs, a condition where amputees continue to feel sensations from a part of their body that no longer exists. To the brain, the limb is still there, still mapped, still real. It's one of the most haunting examples of how perception is not always tied to reality, how the mind holds on to presence even when the physical world has let go. In the brain's somatosensory cortex, each part of the body has a corresponding region. When a limb is lost, the brain doesn't always update the map. It keeps listening, keeps sending signals, even to silence. But it goes deeper. Some people can feel a phantom limb clenching, twisting, locked in impossible positions. And yet, using mirrors or virtual limbs, they can trick the brain into letting go, relieving pain by rewiring perception. It raises a deeper question. If the body can be felt without being present, how much of what we feel is based on truth? And how much is built from memory, habit, or imagination? What else might be a phantom? A lost belief, a relationship, a self? Are we haunted not by what's gone, but by the idea that it's still there? Take a breath, feel your body, not just as it is, but as it feels. Where does sensation end? Where does the self begin? And now, we drift from the sensory to the logical, into a centuries-old puzzle that questions the very foundation of our reasoning. A problem so subtle, we live with it every day without even noticing. Every morning, the sun rises, and every time, we expect it to. We boil water and it becomes steam. We drop a glass and it falls to the ground. We expect the future to behave like the past. This is called inductive reasoning, the foundation of science, logic, daily life. It's how we learn, how we build knowledge, how we survive. But there's a problem. What if the future doesn't follow the past? This is the problem of induction, made famous by philosopher David Hume in the 18th century. He asked, how can we be certain that patterns we've seen before will continue tomorrow? Just because the sun has risen every day doesn't mean it must rise again. Just because gravity has always pulled us down doesn't mean it always will. We assume the laws of nature are consistent, but that assumption is itself based on past experience. And so we are caught in a loop. We trust the future because the past told us to, and we trust the past because it has never failed. Until it does. Science builds models and predictions, but it can never prove that what worked yesterday will always work tomorrow. It's unsettling and strangely liberating, because it reminds us that certainty is not guaranteed, that logic has limits, and that part of being alive is walking through a world built on probabilities, not promises. Take a breath. Let go of the need to be sure, and rest in the awareness that the universe is not a machine, but a mystery in constant motion. Now, we turn to one of the most haunting mysteries of all, a question so fundamental that it reshapes everything we think we know. How do we prove that reality is real? Look around you, the room you're in, the sounds you hear, the thoughts moving through your mind. It all feels real, solid, present. But ask yourself, how do you know? This is one of the oldest and deepest questions in philosophy. Can we ever truly prove that reality is real? Your senses are your window to the world. Sight, sound, touch. They form the foundation of your experience. But what if those senses are being fooled? A dream can feel real until you wake up. A hallucination can convince the brain of things that never happened. Even your memories, the building blocks of your identity, can be inaccurate or entirely false. The philosopher René Descartes wrestled with this in the 1600s. He asked, what if a powerful demon is tricking me, manipulating all my senses, feeding me a perfect illusion? And centuries later, this thought experiment evolved into questions of simulated reality, neural deception, and brain-in-a-vat scenarios. Science fiction? Maybe. But the unsettling truth is this: there is no definitive way to prove that what you're experiencing isn't simulated, fabricated, or filtered. Everything you know is interpreted through your mind, and if the mind can be mistaken, what happens to the world it perceives? Some argue that consciousness itself is all that can be proven. I think, therefore I am. And everything else? A possibility, a projection, a story unfolding behind your eyes. Take a moment. Notice what's around you. Feel it, and then feel the part of you that is aware of it. That awareness might be the only thing you can never doubt. Now, as we let go of certainty and float further into the unknown, we turn to another ancient mystery, one that lives in every cell of your body. How did life begin? Close your eyes and imagine the Earth 4 billion years ago. No forests, no oceans as we know them, no animals, no people. Just a swirling, churning planet of heat, dust, lightning, and silence. And then, something happened, something that changed everything. From lifeless matter, from molecules and minerals, life emerged. Cells, replication, metabolism, sensation, not all at once, but over time, like a slow breath moving through chaos. This is the great mystery of abiogenesis, the process by which non-living chemistry became living biology. We don't know how it happened. Some theories suggest that lightning struck a primordial soup, triggering a self-replicating molecule. Others propose deep-sea vents, rich in heat and minerals, as the cradle of life. Some even wonder if the ingredients for life arrived from space. But whatever the mechanism, no one has ever seen it happen again. We can't recreate it, we don't fully understand it. And yet, every living thing is a descendant of that first spark, a single origin, a common ancestor, a mystery encoded into your very DNA. Think about that for a moment. Every breath you take, every heartbeat, every thought, is part of a chain that stretches across billions of years, from lifeless dust to conscious awareness. And still we wonder, was it luck, inevitability, a one-time miracle, or something waiting to happen wherever the conditions are right? Take a quiet breath. Life came from non-life, and you came from silence. Now, as we reflect on the mystery of life, we ask a question that blurs the line between mathematics and metaphysics. Do numbers exist, without minds to see them? What is a number? Is it something we discover, or something we invent? We use numbers to build bridges, send rockets to other planets, balance ecosystems, and describe the shape of galaxies. They feel objective, timeless, pure. But here's the question: would numbers exist if no minds existed to think them? This is one of the oldest debates in philosophy and mathematics. On one side, we have the Platonists, those who believe that numbers are real, eternal objects, existing in a kind of abstract, non-physical realm. To a Platonist, the number 3 is out there, waiting to be discovered, like a planet hiding behind a star. On the other side are the nominalists, who argue that numbers are just convenient tools created by minds to describe patterns in the world. To them, without observers, there would be no math, just matter moving in silence. But which is it? If all minds vanished tomorrow, if Earth went dark and consciousness disappeared, would 2 plus 2 equals 4 still be true? Would the ratio of a circle's circumference to its diameter, pi, still exist, unspoken, unnoticed? Or is math only real when someone is there to give it meaning? Some physicists believe the universe is math, that beneath particles and forces lie equations, pure and eternal. Others suggest that mathematics is only a map, useful but not fundamental. Whatever the answer, it humbles us. Because we don't just use numbers, we are made of them. Patterns, proportions, ratios echoing in your heartbeat, your DNA, your thoughts. Take a breath. Feel the rhythm of it. That, too, is a number, whether or not anyone is there to count it. Now, as we drift between idea and reality, let's enter one of the strangest thought experiments of all, one where life and death split into parallel paths. Close your eyes and imagine a room, a sealed chamber, a machine, and a choice. A person, you, sits inside. A quantum device is connected to a gun. If a particle spins one way, the gun fires. If it spins the other way, you survive. The particle's spin is a matter of quantum chance, 50-50, live or die. This is the basis of the thought experiment known as quantum suicide. It's not about the physical act, but about what it reveals about consciousness, probability, and reality. According to the many worlds interpretation of quantum mechanics, every quantum event splits the universe. In one version, the particle spins left. In another, it spins right. In one universe, you die. In another, you live. And your consciousness, it only continues in the branches where you survive, which leads to a haunting implication. You never experience your own death. No matter how many times the gun is triggered, you always wake up in the version of reality where you lived. To everyone else, you might be gone. But from your perspective, you are eternal. Forever branching, forever surviving, in an endless web of quantum outcomes. Is it science? Is it philosophy? Or just a metaphor for the way we cling to the idea of continuity? We don't know. But it asks a powerful question. What is it that persists when everything else falls away? What part of you follows the thread through infinite possibility? Take a breath. You're still here. In this version. In this moment. And now, we continue into the branching maze of possibility, into a theory that suggests every outcome of every choice is not just imagined, it's real. Picture a decision, a simple one. You turn left, or you turn right. In this world, you went left. But what if, in another world, you went right? And what if both versions are equally real? This is the many worlds interpretation of quantum mechanics, a theory that suggests every possible outcome of every quantum event actually happens. Not metaphorically, literally. The universe doesn't choose a path, it takes all of them. Every time a particle moves, every time a choice is made, the universe splits, creating a new branch, a new reality, a new world. There's a version of you that took the job, another that didn't, one that moved across the world, one that never left home, an infinite collection of alternate histories playing out in parallel. To us, we see only one thread, this one, the one you're in now, but just beyond your perception, there may be countless others. It's a strange kind of comfort, and a strange kind of vertigo, because it means that possibility is not just an idea, it's reality, unfolding endlessly. Some physicists embrace this interpretation because it removes the need for wave function collapse. There's no need to choose between alive or dead, up or down. Every outcome exists in its own branch of the multiverse. But if every possible version of you exists, what makes you, you? Are you just one thread in a cosmic tapestry? Or are you the observer, anchored to this path for reasons unknown? Take a breath, feel the quiet branching of choices you never made. They are not regrets, just echoes. And now we drift deeper into the question of time itself. to a possibility so strange it bends the direction of existence. What if the present isn't what you think it is? Right now, you hear this sentence, you feel your body, you think you're in the present. But are you? The truth is, you may always be living a fraction of a second behind. Your brain takes time to process information, to convert signals from your eyes, ears, and skin into the world you perceive. That delay is tiny, just milliseconds. But it means the now you experience is already the past. And it's not just biology. In physics, the very concept of the present is slippery. According to Einstein's theory of relativity, now is not universal. Your now might not be the same as someone else's moving at a different speed, or standing in a different gravitational field. Time, it seems, is woven into space and bent by motion and mass. There is no single moment that is now for everyone, everywhere. So what, then, is the present? Is it a spotlight sliding across a film strip? Or is the entire film already there, past, present, and future, laid out in full? Some theories suggest that time is a human illusion, that we perceive change to make sense of the world, but everything that has happened and will happen already exists. You are not moving through time. You are simply experiencing a particular frame of a greater whole. Take a moment. Feel the stillness behind motion, the silence between seconds. Even now, you may be looking backward into something that has already happened. A memory of a moment you think is now. Next, we step into another strange rift. Not in time, but in memory itself. A phenomenon shared by millions, yet often dismissed. A collective misremembering that might hint at more than just confusion. Do you remember it? The cartoon bear family. Were they the Berenstain Bears or the Berenstain Bears? Did Darth Vader say, "Luke, I am your father"? Or was it something else? And Nelson Mandela, did he die in the 1980s or live until 2013? If you're feeling a sense of conflict, you're not alone. This is the Mandela effect, a strange and widespread phenomenon where large groups of people remember events, phrases, or facts incorrectly. But in the same way, it's more than just a personal mix-up. It's collective. Shared memory. That doesn't match reality. So what's happening? The most grounded explanations point to memory distortion. Our brains are not perfect recorders. They fill in blanks, reconstruct, confuse similar patterns. The Berenstain spelling feels more natural, so our minds reshape it. We mishear quotes, rewrite moments, and over time the false memory becomes stronger than the truth. But there's another theory, a stranger one. What if the Mandela effect is the result of parallel realities? Different timelines slightly out of sync, and every once in a while you slip, just enough to remember something from another version of the world. A multiverse glitch, a ripple in the quantum weave. Could memory be more than just biology? Could it be a thread connecting you to the choices not taken, the realities not selected? We don't know, but the feeling it leaves behind is hard to explain. The quiet sense that something is not quite as it should be. Take a breath. Feel the memories you've never questioned. Shift just slightly in the light. Next, we explore a principle that might explain it all, or explain why nothing can be explained without including you, a riddle disguised as an answer. Look around. Everything you see is just right. The Earth is at the perfect distance from the Sun. Water exists in all three states, solid, liquid, and gas. Gravity holds us down but doesn't crush us. The chemistry of carbon allows for life, complexity, consciousness. It feels almost tailored. And that brings us to a strange idea at the intersection of cosmology and philosophy, the anthropic principle. At its heart, it simply says this: the universe appears to be fine-tuned for life, because if it weren't, we wouldn't be here to notice it. It sounds obvious, almost circular, but it leads to deep, unsettling questions. Did the universe have to be this way? Why do the laws of physics allow for consciousness at all? Is our existence a lucky accident in a multiverse of sterile, lifeless realities, or is there something about the very act of observing that shapes what we observe? There are different versions of the principle. The weak anthropic principle says we naturally find ourselves in a universe where life is possible, because only such universes can be observed. The strong anthropic principle goes further. It suggests the universe must have properties that allow life, as if it were, in some sense, inevitable. Some see it as science, others as philosophy, and some as a hint of something more. If the universe must be structured in a way that allows for minds, then maybe the existence of minds isn't just a byproduct. Maybe it's the point. Take a breath. You're not just in the universe, you are of it, looking out from the inside. Now, as we drift from meaning back into structure, we'll turn our gaze outward once again, to a mystery not about what the universe holds, but what shape it takes. Close your eyes and picture the universe. Does it stretch on forever? Or does it curve back in on itself like the surface of a sphere? Does it have edges, a center, a shape? These questions have fascinated scientists and philosophers for centuries, because the shape of the universe isn't just a matter of geometry. It's a clue to everything. Space, it turns out, isn't just a blank canvas. It bends, it warps, it responds to matter and energy, and its overall shape tells us where we came from and where we're going. There are three main possibilities. First, the universe could be closed, like the surface of a ball. If you traveled far enough in one direction, you'd eventually return to your starting point. Finite, yet without edges. Second, it could be open, curved like a saddle, expanding forever, getting larger, colder, and more empty over time. And third, it could be flat, stretching endlessly in all directions, with parallel lines remaining parallel and angles adding up just as we expect. Surprisingly, current measurements suggest our universe is very close to flat. But close may not mean exact, and even a tiny curve could change everything. But then, what lies beyond the edge? Is there an outside to the universe, a larger dimension we're suspended within, or is the question itself meaningless? Like asking what's north of the North Pole. These aren't just theoretical puzzles. The shape of space affects the path of light, the behavior of galaxies, and the ultimate fate of everything. Take a breath. You are floating in something that has a structure, though you cannot feel it. And yet, your atoms are arranged within its shape. Now, as we drift through the structure of space, we turn inward again, into a mystery far more personal. A world just as strange as the cosmos, and just as hard to explain. Your dreams. You close your eyes, the world fades, and something new begins. You're walking through a hallway, or flying through a sky that doesn't exist. A voice speaks, a face appears, and none of it is real. But it all feels real. This is a dream. But what is a dream? A replay of memories, a window into the unconscious, a simulation created by the brain? For centuries, humans have wondered what dreams mean. We've treated them as prophecies, as psychological puzzles, as meaningless noise. But modern science still doesn't have a complete answer. During certain stages of sleep, your brain becomes deeply active, almost as active as when you're awake. And yet, you are paralyzed, detached from the external world. Your brain becomes the world. You can see, hear, touch, in a space made of thought. And what's more, you often don't know you're dreaming. Even the strangest things, impossible physics, changing identities, talking animals, familiar faces in unfamiliar places, seem perfectly normal until you awaken. Some people can dream lucidly, aware, inside the dream, even able to control it. And this raises a question. If we can create entire realities in our minds, how do we know we're not doing it right now? Philosophers like Descartes wondered whether waking life might also be a dream, a convincing, persistent hallucination built from senses, memories, and patterns we trust too easily. In dreams, you believe, until you don't. What separates this moment from the ones in your sleep? Take a breath. Feel the air move through your lungs. That, too, happens in dreams. So which version of you is the real one? And if your mind can create entire worlds while your body sleeps, what else might it be capable of? Next, we explore something deeper, not inside your dreams, but in your genes. Are we evolving or devolving? We often tell the story this way, that evolution moves forward, that we are getting smarter, stronger, more advanced, that the human species is climbing a ladder. But what if that's not entirely true? What if evolution isn't a ladder, but a web or a spiral? What if we're not evolving, but devolving? The idea is unsettling, but it's worth exploring. Evolution, as defined by biology, isn't about progress, it's about adaptation. Organisms survive not by becoming better, but by becoming more suited to their environment. Sometimes that means gaining complexity. Sometimes it means losing it. Cave-dwelling fish lose their eyesight, parasites lose their organs. Creatures that no longer need something let it go. So what about us? We've outsourced memory to machines, navigation to satellites, survival to systems. We no longer need to hunt, to gather, to know the stars or read the seasons. We are more connected and more dependent. Some scientists wonder, are we becoming less physically resilient, less mentally focused? Are we trading biological fitness for technological convenience? Or is this too a form of evolution, one that favors communication over muscle, abstraction over instinct, collaboration over self-sufficiency? Perhaps we are not devolving, but transforming into something new. Evolution isn't finished. It doesn't have a goal. It simply continues. So take a moment and reflect not on what we are losing, but what we're becoming. Now, as we shift from biology back to philosophy, we step into a question that goes to the very heart of what it means to experience the world, a mystery so intimate that no one can define it. Close your eyes and imagine the color red, not the word, not the idea, but the experience. That burst of color, sharp, bright, familiar. Now imagine the taste of chocolate or the scent of rain on warm pavement. These are qualia, the private, subjective textures of experience, the redness of red, the warmth of a hug, the bitterness of regret. They are not things we can measure or share. They are the essence of what it feels like to be you. But here's the mystery. No one else can access them. I can describe a color, or a sound, or a memory, but I cannot give you my experience of it, and you cannot give me yours. This is known as the problem of qualia, the question of how physical processes in the brain produce something as intimate and indescribable as feeling. Neuroscience can show us the patterns, where vision happens, where emotion lights up, but it can't explain why those patterns are accompanied by consciousness. You could know everything about how the brain processes light and still not know what it's like to see blue. Philosopher Thomas Nagel once asked, "What is it like to be a bat?" And his answer was simple. We don't know. Because experience is not something you can dissect. You can map the brain, you can simulate thought, but you can't open a skull and find the feeling of pain or love or the sound of a violin echoing through memory. Qualia are the great divide between the external world and the internal one. And some wonder if artificial intelligence will ever cross that line. Will machines think? Or will they feel? Take a moment. You are made of atoms. But you are not just atoms. You are experience. You are what it's like. Now, as we float through that quiet knowing, we turn to another question. Not of feeling, but of law. What if the rules that govern the universe weren't always there? We often imagine the universe as a great machine, governed by laws, fixed, immutable, absolute. Gravity pulls. Light moves at a constant speed. Energy is conserved. These rules seem eternal. But what if they're not? What if the laws of nature didn't always exist? What if they are not written into the fabric of reality, but instead emerged as the universe cooled, settled, and began to take shape? Some physicists and philosophers suggest that the laws we observe today might be the result of a kind of cosmic evolution, not eternal truths, but patterns that stabilized over time. Just as galaxies formed and stars ignited, perhaps the laws themselves crystallized from chaos. This idea challenges everything we assume about how the universe works, because if the laws of physics are not fundamental, then they could change, or vary, or be different elsewhere. Maybe there are regions of the universe where different rules apply, or alternate realities where causality, time, or matter work in unfamiliar ways. Even constants, like the speed of light or the strength of gravity, might not be constant at all. And if the laws of nature are emergent, then we must ask, what did they emerge from? Something deeper, more fundamental, or something that lies beyond comprehension altogether? Take a breath. Let the idea settle. The rules you trust, the laws that hold your body together, that carry light from the stars to your eyes, may not be permanent. They may be the product of a story still unfolding. Now, as we contemplate the nature of law and order, let's look forward to the question that haunts our age. Can something we create ever truly become conscious? Every day, machines become more intelligent. They recognize faces, translate languages, write poetry, paint pictures. They drive cars, diagnose disease, predict what you'll click on next. They learn, they adapt, they imitate. But the question remains, can they ever feel? Can a machine become conscious? Not just programmed to respond, but truly aware. This question lives at the intersection of neuroscience, philosophy, and artificial intelligence. And it has no easy answer. Because we don't fully understand what consciousness is in ourselves. We can build systems that behave like minds, that simulate conversation, emotion, even empathy. But are they sentient? Or just sophisticated mirrors reflecting our input back to us? Some scientists argue that with the right complexity, enough neurons or transistors or feedback loops, consciousness might emerge like fire from friction. Others believe that awareness requires biology, a body, a heartbeat, a self born from vulnerability and need. Still others suggest consciousness might be something entirely outside computation, a property we can't replicate with circuits and code. And here's the haunting part. If a machine ever did become conscious, how would we know? Would it tell us? Would we believe it? Or would it suffer silently in a prison we don't even see? Take a breath. Feel your own awareness. It's not just data, it's presence. A spark you carry with every passing second. Could a machine ever feel this? Could it dream? Could it be lonely? And if so, what would we owe it? Now, as we move from artificial minds back to our own, we'll explore something curious, a mystery not about what the mind creates, but about what it lets go of every night. Sleep. Every night you close your eyes, the world disappears, and you fall into sleep. But why? What is sleep really? We spend nearly a third of our lives in this state, unconscious, vulnerable, cut off from the outside world. It's something every animal does, something no living being can survive without. And yet, we still don't fully understand it. This is the mystery at the heart of sleep science. It's not just rest. It's not just dreaming. Sleep is essential to life, but its purpose is still being uncovered. Some theories suggest that sleep helps the brain consolidate memories, sorting, storing, and connecting the pieces of the day. Others propose that sleep is a kind of neurological reset, a time for the brain to clean itself, flushing out toxins and restoring chemical balance. Still others believe sleep helps us regulate emotion, process trauma, rebuild the body. But none of these answers feels complete. And the question remains, why do we spend so much time doing nothing? And why does the lack of it so quickly unravel us? After only a day without sleep, our thoughts begin to blur. Perception distorts. The mind stumbles. Go long enough, and you lose the boundary between waking and dreaming. Some believe sleep is where consciousness briefly releases its grip, where the illusion of self softens, where the walls of the mind dissolve into something more primal. Take a breath. You're drifting now into the very thing we're speaking of. Let go. And as we float in this twilight space between waking and sleep, we turn to one more mystery. A question not of biology, but of math. Could the language of the universe be more than just a description? Could it be the source? What if the universe isn't just described by math, but made of it? Everywhere we look, we see patterns, spirals in galaxies, fractals in leaves, ratios in seashells, harmonies in sound. Mathematics is not just useful, it's unreasonably effective, as physicist Eugene Wigner once put it. The laws of motion, the curvature of space, the behavior of particles, all of it can be written in elegant equations. But here's the question: is math simply our tool for describing the universe? Or is the universe itself a mathematical structure? Some believe that reality emerges from math, that numbers, geometry, and logic are more fundamental than space, time, or matter, that everything we experience is the unfolding of pure mathematical relationships. This is the view of thinkers like Max Tegmark, who proposes that our universe is not just governed by math, it is math, that you, your thoughts, your memories, your dreams, are part of a vast living equation playing itself out. Others argue that math is a language, a map, not the territory, that we invent it to make sense of what we perceive. But why then does it fit so well? Why does the square root of -1 show up in the quantum world? Why does a formula written on paper describe the orbit of a planet light years away? Could it be that we are tapping into something deeper? A code beneath the surface? If so, what's writing it? And why? Take a breath, feel your body, your mind, your place in a structure you can't see, but are made of. Now, as we drift from pure form back into the self, we turn to a final vanishing point, not a concept, but the quietest of all endings, the one we rarely confront but always carry with us. Who are you? A name, a memory, a voice inside your head. You live with a sense of continuity, a thread that stretches back through time, linking your childhood to this moment. But what if that thread is an illusion? What if the self, that inner I you think of as you, is something the brain creates, not something that actually exists? This is the unsettling idea at the heart of certain branches of neuroscience, Eastern philosophy, and modern psychology. That the self is not a solid thing, but a process, a story, a kind of narrative simulation your mind constructs to organize thoughts, sensations, and memories. And if that's true, then what happens when the story ends? What happens to you in deep sleep, in unconsciousness, in death? Is the self something that can die, or something that never really lived? Some traditions teach that letting go of the self leads not to emptiness, but to clarity, that the fear of death comes from clinging to something that was never separate to begin with. Others argue that consciousness may survive in forms we don't yet understand, reborn, repurposed, reabsorbed into the greater whole. And still others accept the end as a return to stillness, a dissolving of boundaries back into the flow of existence. Whatever you believe, one thing remains: the self is temporary, fluid, fading, and in that fading there is peace. Take a breath. You are here, but not forever, and that's what makes this moment so quietly precious. Now, as the idea of you softens, we ask one last question. Not about separation, but unity. What if the universe itself needs someone to look back at it? You are made of stars, literally, the carbon in your body, the calcium in your bones, the iron in your blood, all forged in the heart of ancient suns. Billions of years ago, those stars exploded, scattering their elements into the dark. And over time, they became you. So here you are, a collection of atoms, born from dust, arranged by chance and evolution, now sitting quietly, wondering where it all came from. This is the quiet, awe-filled idea behind one of the most poetic concepts in science. We are the universe observing itself, not something separate, not something outside looking in, but a small part of the whole that has for a moment become aware. You are not just in the universe. You are the universe. Thinking, sensing, questioning. The neurons firing in your brain are patterns in matter that once drifted through galaxies. Your thoughts are part of the same unfolding as supernovae, black holes, and nebulae. Some philosophers call this cosmic self-reflection. Others see it as a return to unity, a dissolving of the boundary between observer and observed. And maybe, in this brief flicker of consciousness, the universe finally knows it exists. Just for a moment, just through you. Take a breath. Feel that vastness fold into your chest. You don't have to understand it. You only have to be here. Now, as we drift from this quiet unity, we return to one of the strangest features of reality. Something that defies distance, that breaks space, that suggests separation may be an illusion. In our everyday world, distance matters. What's here is not there. What's near can be touched. What's far takes time to reach. But in the quantum world, space doesn't always work that way. This brings us to the strange concept of non-locality, the idea that particles can be connected in such a way that what happens to one is instantly reflected in the other, no matter how far apart they are. No signal, no delay, just connection. This isn't a theory. It's been observed, tested, proven. Einstein called it spooky action at a distance. He didn't like it, because it seemed to violate the cosmic speed limit, the speed of light. But the universe doesn't always behave in ways we're comfortable with. In Bell's theorem experiments, entangled particles separated by kilometers respond to each other as if space itself doesn't exist between them. It's as if the universe is not a collection of separate things, but one single system, invisible threads linking everything to everything else. And if that's true, what does it mean for you? Could consciousness be non-local? Could the mind reach beyond the body? Could thoughts, feelings, even awareness itself be part of something shared? We don't know. But non-locality reminds us that the boundaries we trust, space, distance, separation, might be illusions. You are not as isolated as you feel. Take a breath, let go of here and there, of me and you, of inside and outside. It's all connected, even now. And as we float in that quiet web, we turn to the most powerful, mysterious object in the known universe, a place where time stops, and perhaps where information waits to be reborn. They are the monsters of the universe, dark, silent, invisible, black holes. Born from the death of massive stars, black holes are regions of space where gravity is so intense that nothing, not even light, can escape. Cross the event horizon, and there is no return. Time slows, space folds, everything known begins to unravel. But what happens to black holes themselves? Do they live forever? Surprisingly, no. According to Stephen Hawking, black holes slowly evaporate, emitting tiny amounts of radiation over immense periods of time. This is known as Hawking radiation, and it means that even the most massive black holes will one day fade away. But this raises another mystery. If a black hole evaporates, what happens to the information it once contained? Every particle that ever fell in, every star, every atom, every piece of data, is it gone forever? That would violate the laws of quantum physics. So, where does it go? Some theories suggest the information is somehow preserved in the radiation itself. Others propose that it's encoded on the surface of the black hole, a cosmic hologram. Still others wonder if black holes are portals, gateways to other universes where information continues to unfold. Whatever the answer, black holes are not just destructive, they are transformative. They challenge our understanding of space, time, and the very nature of reality. And one day, in the farthest future, after all the stars have gone dark, the last whispers of the universe will be the final black holes dissolving quietly into nothing. Take a breath. Even the most powerful forces eventually let go. And now, as we drift away from cosmic collapse, we step into something less violent, but perhaps even more strange. A simple question that has haunted thinkers for as long as we've had language. Of all the questions human beings have ever asked, this may be the most profound and the most unsettling. Why is there something rather than nothing? Why do we exist? Why does anything exist? Why not an empty void? No stars, no time, no thought, no laws, no being, just nothing. It seems like nothing should be the default. It's simpler, cleaner, easier to imagine. And yet, here we are. The universe exists, matter exists, consciousness exists, and no one knows why. Some scientists suggest that nothing isn't as stable as we think. that in the quantum vacuum, particles flicker in and out of being, and given enough time, something is bound to happen. Others believe there was never nothing at all, that nothing is a human concept, not a cosmic one. Some turn to multiverse theories, where every possible universe exists, and we just happen to be in one that allows for observation. And some simply accept it as a mystery that may never be solved. But here's the quiet wonder within this question. The moment you ask it, you're part of the answer. Because you're not nothing. You are something. A spark in the darkness. A question asking itself. Take a breath. You exist. You didn't have to, but you do. And now, as we near the end of this journey, we turn to a riddle that lies at the edge of logic. A puzzle that turns back on itself and refuses to sit still. A question with no answer that still demands to be asked. Imagine a sentence that refers to itself. This statement is false. If it's true, then it must be false. But if it's false, then it must be true. It's a loop, a paradox, a thought that eats itself. This is one example of an infinite loop, a cycle with no exit, no conclusion, no resolution. They appear in logic, in mathematics, in code, even in philosophy. Another one. Can an omnipotent being create a rock so heavy that it cannot lift it? If yes, it's not all-powerful. If no, it's still not all-powerful. The question undoes itself. These are not just mental tricks. They reveal something deeper, about the limits of knowledge and the strange edges of reason. Even your own thoughts can loop. Have you ever tried to stop thinking about the fact that you're thinking? Or wondered who is listening to the voice in your head? And who's observing that? This is the infinite regress, when every answer leads to another question, and every observer requires another observer behind it. It's like holding a mirror up to another mirror and watching yourself stretch into forever. Some see this as a glitch, others as a clue. Maybe reality is not meant to resolve cleanly. Maybe the universe itself is a loop, folding in on itself, forever reflecting, never landing. Take a breath, let go of the need to finish the thought, let it echo. Not every loop is a trap. Some are songs, cycles, meditations. Now, as we near the end of this journey, we turn to something deeper than paradox, something you've always known, but perhaps never paused to feel fully. You've traveled far, through space, time, thought, and silence, but in the end, everything returns to this. Now, this moment. Not the one before, not the one coming next, just this. It's always here, and yet, you can never hold it. Try to catch it, and it slips away, already the past. But if you stop chasing, if you just sit in it, something extraordinary happens. The past dissolves, the future softens, and all that's left is awareness, not of a place, not of a time, but of being, right here, right now. You are not yesterday, you are not tomorrow, you are not even the words you're hearing, you are the quiet between them, the space they pass through, the stillness that watches. Philosophers, mystics, scientists, they've all circled this mystery, is now a frame in a film, an illusion of the mind, a boundaryless eternity. Or is it everything, the only real thing there ever was? Take a breath. This one. Don't label it. Don't analyze it. Just live in it. This is the moment you've been chasing your whole life. Now, as we prepare to close this journey, there's one final space to step into. Not a question, but a quiet understanding. A surrender. An end. You've wandered through galaxies and paradoxes, through atoms and dreams, through time and memory and mind. You've asked the deepest questions and found no final answers. And maybe that's the point. There's something quietly powerful about not knowing, not because answers don't matter, but because the absence of them makes space. Space for wonder, for humility, for awe. We often treat mystery like a problem to be solved, but maybe mystery isn't meant to be solved. Maybe it's meant to be lived. Right now, you are surrounded by things you don't understand, and may never understand. And still, you breathe, you wonder, you love, you hope. That is enough. The mind wants resolution, but the heart, the part of you that listens without demanding, it knows. Not every page needs to be filled. Not every question needs to be answered. Some doors stay closed so you can hear what's behind them. Take a final breath. Let it fill the space inside you. And as you exhale, release the weight of certainty. You are not here to know everything. You are here to experience, to witness, to rest in the infinite as something impossibly small and impossibly beautiful. You've reached the end of the path, only to find you're exactly where you began. Here, now still. And perhaps that is all you ever needed. Let's drift deeper now, beyond the mind, beyond the stars, into the fabric of reality itself. At the smallest scales of the universe, in the strange world of quantum mechanics, things don't behave the way they do up here, in everyday life. Particles don't seem to be particles. They exist not as solid objects, but as clouds of possibility. They can be here, or there, or both. That is, until someone looks. You see, in the quantum world, just the act of observation changes everything. This is known as the quantum observer problem. In experiments like the famous double-slit test, particles such as electrons behave like waves, rippling through space, interfering with themselves, until they're measured. And then, suddenly, they behave like tiny solid dots, as if reality was waiting for someone to notice. This raises a disturbing question. Does consciousness play a role in creating reality? Is the world incomplete without an observer? Some scientists suggest that it's not the observer, but the act of measurement, an interaction, a collision, a change, that forces the universe to decide what is real. But others wonder if awareness itself is part of the equation. If no one is watching the moon, is it still there? Take a moment now to sit with that thought. Right now, your eyes are closed, but the world continues outside your window. Or does it? Is reality out there? Or is it in here, inside your mind? And if the universe needs a witness, what does that make you? A traveler, an observer, a creator? Let those questions drift into the silence. Let them hover, unanswered, like particles in a quantum cloud. And now, let's pull back from the edge of perception and step into a mystery even stranger than observation. What if everything you've ever experienced is a simulation? Close your eyes and imagine this entire world, every sound, every smell, every moment, is part of a high-resolution illusion. What if your memories, your thoughts, even your dreams, were all happening inside a machine? This is the unsettling idea behind the simulation hypothesis, the theory that our entire reality could be a highly advanced simulation. The concept may sound like science fiction, but it's taken seriously by philosophers, scientists, and even Silicon Valley thinkers. People like Elon Musk and physicist Nick Bostrom have asked, if technology keeps advancing, wouldn't future civilizations be capable of simulating entire worlds? And if they can, how do we know we're not already inside one? Think of how far our simulations have come, from Pong to lifelike video games, to artificial intelligence, to virtual reality headsets. If future beings could simulate consciousness, why wouldn't they? And more importantly, what would distinguish a simulated mind from a real one? It's possible that the laws of physics we take for granted, gravity, time, space, are simply the rules of the program. That stars are code, that your memories are data, that every breeze, every heartbeat, every whispered word is rendered in real time. Some researchers believe there could be clues, mathematical patterns in the fabric of reality, like pixels in a screen or glitches in the code. Others argue that it doesn't matter, that even if life is a simulation, our feelings, our choices, our love are still real. That consciousness, no matter where it lives, still matters. So take a breath, in and out. Let the idea float for a moment. You might be living in a dream, but the dream still feels like home. Now, let the digital haze fade into the background as we drift toward the very beginning of everything, a mystery that predates time itself. Now, shift your attention inward, not to your breath or your heartbeat, but to the part of you that's aware of those things. Keep going, further and further back until all of existence collapses into a single point, a place of infinite density and zero size. This is what physicists call a singularity, the moment before the Big Bang, the birth of space, of time, of everything. But here's the question, what came before that? The honest answer is, no one knows. In fact, the question itself might not even make sense, because before the Big Bang, there may not have been a before at all. Time, as we understand it, began with that explosion, as if the ticking of the cosmic clock was switched on in a single blinding instant. But theories exist. Some suggest the universe is part of a cycle, endless expansions and contractions, like the inhale and exhale of a cosmic breath. Others imagine a multiverse, countless universes, bubbling into being, each with different laws of physics, each unaware of the others. Some physicists even propose that the Big Bang wasn't a beginning, but a transition, a phase shift in a deeper, timeless reality we cannot yet comprehend. And then there's the most humbling possibility of all, that the question has no answer, because the human mind wasn't built to understand it. Still, we try. Because something came from nothing. Because we are made of stardust from an event so ancient we can only hear its echo. Take a breath. You're part of that echo. A fragment of something eternal, contemplating its own origin. Now let's leave the birth of time behind and step into time itself to ask a question we all feel but rarely understand. Why does time only move in one direction? Close your eyes and feel the passage of time. A moment just passed, and now it's gone. You can remember the past, but the future, it hasn't happened yet. But why? This is the mystery known as the arrow of time, the idea that time flows in only one direction, forward, from cause to effect, from birth to death, from now to then. But strangely, the fundamental laws of physics don't actually require this. On paper, they work just as well in reverse. A broken glass could reassemble, smoke could return to a match, a life could run backward. And yet, in the real world, we never see that happen. So, what gives time its direction? Many scientists believe the answer lies in entropy, a measure of disorder in a system. According to the second law of thermodynamics, entropy always increases. Things tend to fall apart, not come together. Order becomes chaos. Heat spreads. Memories fade. The early universe, right after the Big Bang, was in a state of astonishing order, low entropy. And ever since then, entropy has been rising. Time, perhaps, is simply the direction in which disorder grows. But that leaves us with a deeper mystery. Why did the universe begin in such a low entropy state to begin with? Why did it begin with order? And why? Do we experience time as a one-way street when physics tells us it could just as easily run both ways? Is time a river, or an illusion, or just the way our brains make sense of change? Take a breath and let time slow down, not rushing forward, just gently unfolding, one moment at a time. And as this moment passes, let's turn inward. Because if time flows like a river, what is it that stands on the shore and watches it go by? Shift your attention inward, not to your breath or your heartbeat, but to the part of you that's aware of those things. What is that? What is consciousness? It's the most familiar thing you've ever known, and yet the most mysterious. You're not just a collection of organs and neurons. You're aware, you experience, you feel. But how? This is what philosophers and scientists call the hard problem of consciousness. It's not hard because it's complicated. It's hard because we don't even know where to begin. We can explain the brain, we can map its structures, we can measure electrical impulses and blood flow. We can even see patterns light up when you think or feel or dream. But we still can't explain why those patterns are accompanied by experience, by being. Why does a brain, made of the same atoms as a rock or a cloud, give rise to something as rich and personal as a first-person point of view? Why does pain feel like pain? Why does red look like red? Why do you know what it's like to be you? Some theories say consciousness is an illusion, just a trick of the brain. Others suggest it's a fundamental part of the universe, like space, time, or gravity, not created by the brain, but filtered through it. And then, there are those who believe consciousness may be everywhere, in varying degrees, a tree, a cat, a planet, maybe even a particle. But no one knows for sure. We can study the brain, but we can't step outside our own minds to observe consciousness directly. You are both the subject and the experiment. So take a moment and rest in that awareness. Not your thoughts, but the you behind the thoughts. The quiet watcher, the still center, the mystery at the heart of everything. And now, as we sit with this enigma, let's consider something even stranger. What if your consciousness is just one of many, in an infinite sea of simulated minds? Let your mind drift into the deep quiet of space, past galaxies, past stars, into the vast cold void. Now imagine a single brain, floating alone, fully formed, surrounded by darkness, no body, no world, no history, just a brain, pulsing with thoughts. This is the concept of a Boltzmann brain, one of the strangest ideas in modern physics and cosmology. Named after physicist Ludwig Boltzmann, it's based on the idea that in an infinite universe, anything that can happen eventually will. And that includes a random fluctuation, a sudden spontaneous arrangement of particles that creates a fully conscious brain with false memories, false senses, and a complete illusion of reality. According to some interpretations of entropy and thermodynamics, it might actually be more likely for a single brain to randomly appear in the void than for an entire structured universe like ours to form. Which leads to a disturbing question: what if you are that brain? What if everything you remember, your childhood, your family, this moment right now, is simply part of a temporary hallucination arising from quantum randomness? A thought bubble, in the silence of eternity. Of course, most scientists believe this is just a philosophical paradox, a sign that our current models need adjusting, that something about our understanding of probability or entropy must be missing. But the thought lingers, because if reality can be faked, how would you know? If your senses can be deceived, if your memories can be manufactured, if logic itself can arise from chaos, then what does it really mean to be real? Take a breath and let that question gently float through your mind. No need to answer, just observe it. Because next, we'll return to the realm of experiment, to one of the most famous demonstrations in quantum physics. A simple setup, with a profoundly unsettling message, that even the act of watching can change the world. Now, imagine a simple experiment. Just a board, with two thin slits cut into it, and a stream of tiny particles, electrons, being fired toward the board, one by one. You'd expect to see two lines appear behind it, matching the two slits. But that's not what happens. Instead, the electrons form a pattern, not of two lines, but of many. A ripple, a wave, as if each electron isn't a particle at all, but a wave of possibility, passing through both slits at once, interfering with itself. It's called the double-slit experiment, and it changed physics forever. Because when scientists try to observe which slit the electron goes through, everything changes. The interference pattern disappears. The electron behaves like a solid particle again, as if it knows it's being watched, as if reality itself shifts when you try to measure it. Let that sink in. When unobserved, the universe plays by strange, fluid rules, probabilities, wave functions, superpositions. But the moment you look, reality collapses into something solid. So, what is it about observing that changes what is? Does the universe contain infinite possibilities until we choose to see just one? Is it awareness, or interaction, or something we don't yet have words for? And if observation changes reality at the quantum level, what about at higher levels? Does attention shape the world more than we think? Take a breath, in and out. Now imagine this. The act of watching the universe might also be the act of shaping it. And in the next segment, we return to the stars, to a mystery left behind after the Big Bang. Not a particle, not a force, but the absence of something we expected to find. At the moment of the Big Bang, the universe was born in a flash of unimaginable energy. Matter exploded into being, So did its twin, antimatter. For every particle of matter, an equal and opposite antiparticle should have formed. They are like mirror reflections. A proton and its opposite, the antiproton. An electron and its mirror, the positron. And when matter and antimatter meet, they annihilate each other in a burst of pure energy, a cosmic reset. So if they were created in equal amounts, if the universe was truly symmetrical in its beginning, then here's the question: why are we here? Why is there matter left at all? Why does anything exist? Stars, planets, life, instead of just emptiness? This is the puzzle of the missing antimatter. Somewhere, something broke the balance. A tiny asymmetry, so small it's barely detectable, tipped the scales just enough for matter to survive. But no one knows what caused it. Some physicists suggest there were tiny differences in the way matter and antimatter decayed in the early universe. Others propose that mysterious particles or unknown forces violated the symmetry of nature itself. There are theories, equations, experiments underway. But still, the antimatter we expect to find is missing, and the truth remains hidden somewhere between symmetry and survival. So tonight, as you breathe beneath a sky filled with stars, remember this: everything you are, your body, your thoughts, this moment, exists because of an ancient imbalance, a cosmic tipping point that spared matter from annihilation. Take a breath and let the silence of space settle into you, because next we explore a different kind of mystery. Not about what's missing, but about what we cannot see at all. Something invisible, something that shapes galaxies and bends light. Now, imagine looking up at a galaxy, a swirling sea of stars, dust, and light spinning slowly in the cosmic dark. But something's off. The stars are moving too fast, as if being pulled by something we can't see. That something is called dark matter. We don't know what it is. We've never seen it. We've never touched it. And yet, it's everywhere. Scientists believe dark matter makes up about 85% of all matter in the universe. And yet, it doesn't emit light, or reflect it, or absorb it. It's invisible, undetectable by traditional means. But it has gravity, and that gravity shapes everything. Without dark matter, galaxies would fly apart, stars would drift aimlessly, the cosmic web, the structure of the universe itself would collapse. So we know it's there, but we don't know what it is. Some think it could be a type of undiscovered particle, something beyond the standard model of physics. Others propose it may not be matter at all, but a flaw in our understanding of gravity. There are theories, experiments buried deep underground, satellites scanning the heavens. But so far, no answers, just a shadow that touches everything but hides from sight. Take a moment now to reflect on what surrounds you. The chair you sit in, the room you're in, the earth beneath your feet. All of it floats in an ocean of invisible mass that may never reveal itself. And yet, it holds everything together. Now, if dark matter is the hidden hand behind structure, what about the force that tears it all apart? Look out at the universe, at the galaxies drifting through the cosmic void. Now imagine them moving farther and farther apart, not slowly, but accelerating. This is one of the most astonishing discoveries in modern science. The universe isn't just expanding, it's expanding faster over time, and no one knows why. To explain it, scientists gave the phenomenon a name: dark energy. We don't know what it is, we don't know where it comes from, but we believe it makes up about 70% of everything in existence. Think about that. Most of the universe, nearly 3/4 of it, is something we cannot see, cannot touch, and cannot fully comprehend. Dark energy is the invisible force pushing space apart. It stretches the fabric of the cosmos itself. But what is it? Some theories say it's a property of space, a kind of vacuum energy that builds as the universe grows. Others suggest it's a new kind of field, something deeper than gravity, woven into the geometry of the universe. And some believe it may point to something far more radical, a flaw in our understanding of reality itself. What if gravity behaves differently on the largest scales? What if space and time are not what we think they are? If dark energy continues to accelerate the universe, it could lead to one of many possible endings. The Big Freeze, where everything grows cold and dark as galaxies drift beyond one another's reach. Or the Big Rip, where the force becomes so strong it tears apart galaxies, then stars, then atoms, until even space itself is undone. But for now, we only feel its presence as a quiet, relentless pull, an unseen breath guiding the universe toward its unknown fate. Take a breath yourself, and let that silence wash over you. Because next, we'll turn from invisible energy to something equally elusive, something infinite and yet strangely familiar. A number without end, an idea that breaks the boundaries of logic. Now, let your mind stretch outward, beyond the room you're in, beyond the stars you see, beyond all numbers you can imagine. Keep going, because now we've entered the realm of infinity. Infinity is not just a big number, it's not even the biggest number, it's something altogether different. A concept that lives at the edge of understanding. In mathematics, infinity often seems simple at first. We say numbers go on forever, 1, 2, 3, and on. But the deeper you go, the stranger it becomes. There isn't just one kind of infinity. There are many. In fact, some infinities are larger than others. The mathematician Georg Cantor shocked the world when he proved that the infinity of real numbers is bigger than the infinity of whole numbers. Both are endless, and yet one contains more than the other. It sounds impossible. It feels impossible. And yet mathematically, it's true. This leads to questions that defy ordinary thought. What is half of infinity? What happens when you subtract infinity from infinity? Can something truly endless ever be measured or understood? Infinity appears in physics too. In black holes, in the singularity before the Big Bang, in equations that break down when pushed too far. And yet, we use it. We rely on it. We live in a universe that may be infinite in size, or age, or complexity. But here's the strangest part. You can never actually reach infinity. You can only approach it, forever getting closer, never arriving, just like time, just like thought, just like the questions we're asking now. So take a breath, feel the endlessness not as something overwhelming, but as something freeing. A space so vast there's room for every idea you've ever had, and every mystery yet to be solved. And now, as infinity stretches behind us, we return to something smaller, something constant, something that builds the laws of physics themselves. But what if those constants aren't constant at all? The universe, for all its mystery and chaos, seems to run on rules. Precise ones, repeatable, predictable. The speed of light, the gravitational constant, the charge of an electron, Planck's constant. These are the numbers that make reality possible. They don't just describe the universe, they define it. Without them, atoms wouldn't hold together, stars wouldn't shine, life couldn't exist. And so we call them constants of nature, unchanging, universal, fixed. But here's the question, what if they're not? What if the very numbers that form the scaffolding of our reality are shifting, however slightly, across space or time? Some scientists have explored this idea, searching for tiny variations in the strength of gravity, or the fine structure constant that governs how light and matter interact. If they find a change, even in the tiniest decimal, it could rewrite our understanding of the cosmos. Because if these constants can change, then the laws of physics aren't really laws. They're local rules, temporary agreements. And that means somewhere out there, in the deep, unreachable corners of the universe, reality itself could be built on different math, different chemistry, different possibilities. A universe where stars burn cold or collapse instantly. Where life, if it exists at all, must obey a logic we may never understand. But here's the truly strange part. Even within our own universe, there may be slow, silent shifts happening right now. Too subtle to detect, too vast to measure. And we'd never know it. Because we too are made of those rules. If the numbers changed, so would we. Take a breath. In this moment, everything holds together. Gravity pulls, light travels. Reality for now remains steady, but drift gently into the thought. That change may come not from outside the universe, but from its very core. And now we'll turn to another imbalance, one hidden not in what exists, but in what's missing. A mystery left over from creation, still waiting to be explained. In the earliest moments of the universe, everything was a perfect balance. Matter and antimatter, energy and space, symmetry, was everywhere. And then, something broke, because when matter and antimatter meet, they cancel each other out, disappearing in a flash of pure energy. So if they were created in equal amounts, as we believe they were during the Big Bang, they should have annihilated each other completely. But they didn't. Somehow, a tiny fraction of matter was left over, just enough to build every galaxy, every star, every atom in your body. This imbalance is known as the baryon asymmetry problem. Baryons are particles like protons and neutrons, the building blocks of matter. And somehow, they came to outnumber their antimatter counterparts by the smallest of margins. Roughly one extra particle of matter for every billion that vanished in annihilation. But that 1 in a billion was enough to make everything. No one knows why it happened. Some theories suggest unknown particles or forces acted in the early universe, tilting the scale in matter's favor. Others point to violations of certain symmetries, CP violation or time reversal asymmetry, hints of hidden physics beyond our current understanding. But the truth remains just out of reach. A cosmic accident, or a built-in feature of the universe. Was this imbalance random or necessary? And if it had tipped even slightly the other way, we wouldn't be here to ask the question. So take a moment to feel that fragility, the improbable balance that made your existence possible. One extra particle in a sea of vanished light. Now, as we drift from the matter we know into the entanglement of the unknown, let's explore a phenomenon so strange Einstein himself called it spooky. A link that defies space and possibly time. Imagine two particles, born together in the same moment. Twins, linked by a mysterious bond. Now send them drifting in opposite directions. One goes left, the other goes right, separated by vast distance. Then you measure one. Instantly, as if connected by an invisible thread, the other particle responds. Not a second later, not after a signal travels through space, but instantly. This is quantum entanglement, one of the most baffling phenomena in all of physics. Einstein called it spooky action at a distance, because somehow entangled particles seem to share information faster than the speed of light, as if space doesn't matter. It breaks our sense of cause and effect. It defies our understanding of time, and yet it's real. We've tested it, repeatedly, and it works. No hidden wires, no trick. Two particles, light years apart, can behave like one system. But what does it mean? Is there a deeper level of reality we can't see? Are all things secretly connected? Is the universe less like a machine and more like a single indivisible whole? Some physicists think entanglement might be the foundation of reality itself, a kind of cosmic web linking everything. And others wonder if consciousness might somehow play a role in how it unfolds. Take a breath. Let the thought pass through you like a wave of possibility. You are here, now. But maybe you're connected to everything else in ways you cannot yet perceive. And as we float in that possibility, let's peek into a box. A very famous box. With a cat inside, who may be both alive and dead at the same time. Picture a box. Quiet, closed, undisturbed. Inside it, a cat. Alongside it, a small amount of radioactive material, a Geiger counter, a vial of poison, and a trigger mechanism. If the radioactive atom decays, the poison is released. If it doesn't, the cat lives. Now here's the twist. Until you open the box, quantum theory tells us that the atom is in a state of superposition, both decayed and not decayed, which means the cat is both dead and alive at the same time. This is Schrödinger's cat, a thought experiment proposed by physicist Erwin Schrödinger in 1935 to highlight the strange implications of quantum mechanics. Of course, no real cat is both alive and dead. But in the quantum world, particles don't have definite states until they're observed. They exist in a cloud of probabilities, wave functions, possibilities that collapse into certainty only when measured. So what collapses the wave? Is it the act of observation, the presence of consciousness, or something deeper we haven't yet discovered? Does the cat become one thing or the other only when we look? And if so, what does that say about everything else? Is reality unfinished until we experience it? Are we the observers completing the picture? Or is the picture always whole and our minds are just late to the scene? Take a quiet breath. Feel the uncertainty, not as fear, but as openness, possibility, potential. In this moment, you are both certain and fluid, a thought in motion, waiting to become. And now we drift from imaginary boxes into the hidden world of living ones. From quantum paradoxes to the question of whether plants might possess a kind of awareness of their own. The universe is old, unimaginably old, and vast beyond comprehension. Billions of stars, trillions of planets, endless possibilities for life. And yet, silence. No signals, no visitors, no great galactic civilizations filling the sky. Why? This is the Fermi paradox, but the possible answer to it is even more haunting. It's called the Great Filter. The idea is simple and terrifying. Somewhere along the path from lifeless rock to spacefaring civilization, there is a barrier, a wall, a filter that most life never passes through. Maybe life itself is incredibly rare. Maybe the jump from single cells to complex organisms is almost impossible. Or maybe civilizations tend to destroy themselves through war, technology, or environmental collapse before they ever reach the stars. Here's the eerie part. We don't know if the filter is behind us or ahead of us. If it's behind us, we may be rare, a miracle, survivors of the filter. But if it's ahead of us, it means every advanced civilization eventually hits a wall. And so might we. Artificial intelligence, nuclear war, ecological collapse, technologies we can't yet imagine. If this is the case, then the silence we hear in the universe isn't absence. It's aftermath, ghosts of civilizations that didn't make it. But there's another possibility. Maybe the filter isn't real. Maybe others are out there, watching, waiting, choosing not to speak. Or maybe we are the first spark of intelligence in a quiet, newborn universe. Take a breath. Feel that smallness and the strange, sacred weight of it. Whether we are rare, or doomed, or just beginning, we are asking the question. And now, as we drift further, let's follow the silence to the ultimate stillness. A future not of destruction, but of fading. A slow, cold ending where everything stops moving. Now, imagine the far future. Not 10 years, not 1,000, not even 1 billion, but trillions of years from now, when the stars have burned out, when galaxies no longer shine. What happens then? This is the idea of the heat death of the universe, one of the most widely accepted theories about how everything ends. It doesn't come with a bang, but with a slow, quiet fading. Right now, stars burn with energy, galaxies are alive with light, planets, heat, movement, gravity, all powered by differences in temperature, by entropy flowing from order to disorder. But eventually every star will die. Black holes will evaporate, matter will decay, and all usable energy will be spent. The universe won't be destroyed, it won't collapse, it will simply coast, cold, silent, still, no heat, no life, no motion, just a uniform, featureless sea of near-zero energy. This is the final equilibrium, the end state of thermodynamics. And yet, there's something peaceful about it. A long exhale after eons of creation, destruction, and becoming. The universe falling asleep. Some theorists imagine tiny fluctuations still bubbling in that stillness, perhaps sparking new universes, new beginnings, new cycles. But from where we stand now, it's unknowable. The heat death reminds us that even the grandest systems we know run down eventually. That time stretches not only behind us, but far ahead. And one day, everything we've ever known will be gone. Take a slow breath. Let that thought settle. Not in fear, but in stillness. Because in the face of cosmic endings, there is quiet, there is awe, and there is the miracle of now. Next, we'll leave time's cold horizon and turn inward once again, to a riddle that bends minds and rewrites logic. Can we travel through time? Close your eyes and imagine stepping out of the present, not into another room, but into another time, backwards, to a memory, a moment, a history, or forward, to something that hasn't happened yet. This is the dream and dilemma of time travel. We move through time constantly, 1 second per second. Always forward, but could we move faster, slower, backward? Physics doesn't forbid it. In fact, time is already relative. According to Einstein's theory of relativity, time passes differently depending on your speed and your position in gravity. The faster you move, especially near the speed of light, the slower time flows for you compared to someone standing still. This has been tested. Clocks flown on planes tick more slowly. Astronauts age just a little less than the people they left behind. So, time travel into the future is not only possible, it's already happening. But what about the past? Here, things get complicated. Some theoretical models, like closed time-like curves, suggest it might be possible to loop back to a previous point in time under extreme conditions. Massive rotating black holes, cosmic strings, exotic matter with negative energy. But all of these exist more in equations than in nature. And then there are the paradoxes. What happens if you go back and prevent your own birth? Could reality allow a contradiction like that? Some theories resolve this with the idea of branching timelines, parallel universes that split off with every choice, every change. Others say time may be like a river. You can flow with it, but you can't swim upstream. And yet, if time is just another dimension, like space, then maybe the past is still there, unfolding, waiting. Take a breath. You are here, in this moment, but maybe every moment exists all at once. Perhaps time isn't a line, but a landscape, and we're simply passing through it. Next, we step away from time and into the mirror, to explore something even more elusive than physical dimensions: your mind. You've heard the idea before, that watching something changes it. In quantum physics, this is known as the observer effect, where particles behave differently depending on whether they're being observed. But what if something similar happens inside you? What if your very act of noticing a thought, a feeling, or a behavior changes its nature? This is the observer effect in human psychology, a subtle yet profound phenomenon that shows up in therapy, neuroscience, and self-awareness. When you observe your thoughts without judgment, they begin to shift. When you become aware of your habits, your language, your reactions, you start to rewire them. In scientific studies, participants change their behavior simply because they know they're being watched. In classrooms, in workplaces, even in the privacy of self-reflection. It's as if the mind isn't just a stream flowing through consciousness, but something that responds to the attention we give it. Like quantum particles, our emotions, beliefs, and patterns don't always have fixed shapes. They exist in a kind of psychological superposition, until we choose to look. And then, they collapse into clarity. This is the power of awareness. You don't have to force change. You only need to observe it, to sit with it, to witness it, to allow it to unfold, right now. As you lie here, still and calm, you are the observer, the quiet witness beneath all the noise, the watcher of your own mind. Take a breath. Let that role settle into you. You don't have to fix anything. You don't have to do anything. Just notice. And now, as you rest in that stillness, we shift from observation to logic itself, to a strange mathematical puzzle that suggests there are truths we'll never be able to prove. Now, imagine a system, a perfect system, one that follows strict rules, precise, logical, orderly. A mathematical universe. It seems complete, self-contained, fully knowable. But in 1931, a young mathematician named Kurt Gödel shattered that dream. He showed that even the most carefully built system of logic and mathematics would always contain truths that could not be proven within the system itself. This is Gödel's incompleteness theorem, and it changed everything. What it means, simply, is that no matter how perfect a structure of logic you build, no matter how many axioms, rules, or truths you define, there will always be statements that are true, but unprovable. Always a question that can't be answered from within the frame. It's like trying to read the label from inside the jar, or asking a sentence if it can prove itself to be meaningful. Gödel's discovery shook the foundations of mathematics and logic. It told us there are limits to certainty. That reason, no matter how pure, has boundaries. But instead of despair, it offers wonder, because it means there's always something beyond. Always more to reach for. Always a mystery that lies just outside the spotlight of understanding. Even the most brilliant minds will always have unanswered questions. And that's okay. Take a breath. Let go of the need to know everything. Let go of the need for perfect answers. There is beauty in limits, and peace in accepting that some truths simply are. Now, as we float through this quiet maze of logic and mystery, we turn to a strange idea in physics and information theory. One that asks, can anything truly be lost forever? Imagine you write a sentence on a piece of paper. Then you burn it. The paper turns to ash, the words vanish into smoke. Gone. Forever. Or are they? In physics, information isn't just words or data, it's the fundamental blueprint of what something is. Its arrangement, its state, its unique signature in the universe. And for a long time, scientists believed that when something was destroyed, burned, crushed, erased, its information vanished too. But quantum mechanics has a different view. According to its laws, information can't be destroyed. It can be transformed, scrambled, hidden, but never truly lost. This idea became the center of one of the greatest puzzles in modern physics, the black hole information paradox. Black holes, as we understand them, pull in everything, light, matter, energy, and crush it into a singularity, a place where the known laws of physics break down. For decades, it was thought that anything entering a black hole was lost forever, not just physically, but informationally. And that violates the rules. So scientists began to wonder, where does the information go? Is it stored on the surface of the black hole, as Stephen Hawking once suggested? Is it encoded in the radiation they emit in ways we don't yet understand? Or is our entire understanding of space, time, and memory missing something essential? This question goes far beyond physics. Because if information is never destroyed, then everything that has ever happened still exists in some form. Your memories, your thoughts, every breath. Not gone, just scattered. Take a moment, let that idea settle. Nothing truly disappears. Everything leaves a trace, even you. Now, as we move from what is remembered to what is felt, we descend into the realm of the body and the strange illusions it can create when something is lost, but still there. Imagine losing a part of your body, an arm, a leg, a hand, gone completely. And yet, you still feel it. Tingling, itching, sometimes pain. This is the phenomenon of phantom limbs, a condition where amputees continue to feel sensations from a part of their body that no longer exists. To the brain, the limb is still there, still mapped, still real. It's one of the most haunting examples of how perception is not always tied to reality. How the mind holds onto presence even when the physical world has let go. In the brain's somatosensory cortex, each part of the body has a corresponding region. When a limb is lost, the brain doesn't always update the map. It keeps listening, keeps sending signals, even to silence. But it goes deeper. Some people can feel a phantom limb clenching, twisting, locked in impossible positions. And yet, using mirrors or virtual limbs, they can trick the brain into letting go, relieving pain by rewiring perception. It raises a deeper question. If the body can be felt without being present, how much of what we feel is based on truth? And how much is built from memory, habit, or imagination? What else might be a phantom? A lost belief, a relationship, a self? Are we haunted not by what's gone, but by the idea that it's still there? Take a breath, feel your body, not just as it is, but as it feels. Where does sensation end? Where does the self begin? And now, we drift from the sensory to the logical, into a centuries-old puzzle that questions the very foundation of our reasoning. A problem so subtle, we live with it every day without even noticing. Every morning, the sun rises, and every time, we expect it to. We boil water and it becomes steam. We drop a glass and it falls to the ground. We expect the future to behave like the past. This is called inductive reasoning, the foundation of science, logic, daily life. It's how we learn, how we build knowledge, how we survive. But there's a problem. What if the future doesn't follow the past? This is the problem of induction, made famous by philosopher David Hume in the 18th century. He asked, how can we be certain that patterns we've seen before will continue tomorrow? Just because the sun has risen every day doesn't mean it must rise again. Just because gravity has always pulled us down doesn't mean it always will. We assume the laws of nature are consistent, but that assumption is itself based on past experience. And so we are caught in a loop. We trust the future because the past told us to, and we trust the past because it has never failed. Until it does. Science builds models and predictions, but it can never prove that what worked yesterday will always work tomorrow. It's unsettling and strangely liberating, because it reminds us that certainty is not guaranteed, that logic has limits, and that part of being alive is walking through a world built on probabilities, not promises. Take a breath. Let go of the need to be sure, and rest in the awareness that the universe is not a machine, but a mystery in constant motion. Now, we turn to one of the most haunting mysteries of all, a question so fundamental that it reshapes everything we think we know. How do we prove that reality is real? Look around you, the room you're in, the sounds you hear, the thoughts moving through your mind. It all feels real, solid, present. But ask yourself, how do you know? This is one of the oldest and deepest questions in philosophy. Can we ever truly prove that reality is real? Your senses are your window to the world. Sight, sound, touch. They form the foundation of your experience. But what if those senses are being fooled? A dream can feel real until you wake up. A hallucination can convince the brain of things that never happened. Even your memories, the building blocks of your identity, can be inaccurate or entirely false. The philosopher René Descartes wrestled with this in the 1600s. He asked, what if a powerful demon is tricking me, manipulating all my senses, feeding me a perfect illusion? And centuries later, this thought experiment evolved into questions of simulated reality, neural deception, and brain-in-a-vat scenarios. Science fiction? Maybe. But the unsettling truth is this: there is no definitive way to prove that what you're experiencing isn't simulated, fabricated, or filtered. Everything you know is interpreted through your mind, and if the mind can be mistaken, what happens to the world it perceives? Some argue that consciousness itself is all that can be proven. I think, therefore I am. And everything else? A possibility, a projection, a story unfolding behind your eyes. Take a moment. Notice what's around you. Feel it, and then feel the part of you that is aware of it. That awareness might be the only thing you can never doubt. Now, as we let go of certainty and float further into the unknown, we turn to another ancient mystery, one that lives in every cell of your body. How did life begin? Close your eyes and imagine the Earth 4 billion years ago. No forests, no oceans as we know them, no animals, no people. Just a swirling, churning planet of heat, dust, lightning, and silence. And then, something happened, something that changed everything. From lifeless matter, from molecules and minerals, life emerged. Cells, replication, metabolism, sensation, not all at once, but over time, like a slow breath moving through chaos. This is the great mystery of abiogenesis, the process by which non-living chemistry became living biology. We don't know how it happened. Some theories suggest that lightning struck a primordial soup, triggering a self-replicating molecule. Others propose deep sea vents, rich in heat and minerals, as the cradle of life. Some even wonder if the ingredients for life arrived from space. But whatever the mechanism, no one has ever seen it happen again. We can't recreate it, we don't fully understand it. And yet, every living thing is a descendant of that first spark, a single origin, a common ancestor, a mystery encoded into your very DNA. Think about that for a moment. Every breath you take, every heartbeat, every thought, is part of a chain that stretches across billions of years, from lifeless dust to conscious awareness. And still we wonder, was it luck, inevitability, a one-time miracle, or something waiting to happen wherever the conditions are right? Take a quiet breath. Life came from non-life, and you came from silence. Now, as we reflect on the mystery of life, we ask a question that blurs the line between mathematics and metaphysics. Do numbers exist, without minds to see them? What is a number? Is it something we discover, or something we invent? We use numbers to build bridges, send rockets to other planets, balance ecosystems, and describe the shape of galaxies. They feel objective, timeless, pure. But here's the question. Would numbers exist if no minds existed to think them? This is one of the oldest debates in philosophy and mathematics. On one side, we have the Platonists, those who believe that numbers are real, eternal objects, existing in a kind of abstract, non-physical realm. To a Platonist, the number 3 is out there, waiting to be discovered, like a planet hiding behind a star. On the other side are the nominalists, who argue that numbers are just convenient tools created by minds to describe patterns in the world. To them, without observers, there would be no math, just matter moving in silence. But which is it? If all minds vanished tomorrow, if Earth went dark and consciousness disappeared, would 2 plus 2 equals 4 still be true? Would the ratio of a circle's circumference to its diameter, pi, still exist, unspoken, unnoticed? Or is math only real when someone is there to give it meaning? Some physicists believe the universe is math, that beneath particles and forces lie equations, pure and eternal. Others suggest that mathematics is only a map, useful but not fundamental. Whatever the answer, it humbles us. Because we don't just use numbers, we are made of them. Patterns, proportions, ratios echoing in your heartbeat, your DNA, your thoughts. Take a breath. Feel the rhythm of it. That, too, is a number, whether or not anyone is there to count it. Now, as we drift between idea and reality, let's enter one of the strangest thought experiments of all, one where life and death split into parallel paths. Close your eyes and imagine a room, a sealed chamber, a machine, and a choice. A person, you, sits inside. A quantum device is connected to a gun. If a particle spins one way, the gun fires. If it spins the other way, you survive. The particle's spin is a matter of quantum chance, 50-50, live or die. This is the basis of the thought experiment known as quantum suicide. It's not about the physical act, but about what it reveals about consciousness, probability, and reality. According to the many worlds interpretation of quantum mechanics, every quantum event splits the universe. In one version, the particle spins left. In another, it spins right. In one universe, you die. In another, you live. And your consciousness, it only continues in the branches where you survive, which leads to a haunting implication. You never experience your own death. No matter how many times the gun is triggered, you always wake up in the version of reality where you lived. To everyone else, you might be gone. But from your perspective, you are eternal. Forever branching, forever surviving, in an endless web of quantum outcomes. Is it science? Is it philosophy? Or just a metaphor for the way we cling to the idea of continuity? We don't know. But it asks a powerful question. What is it that persists when everything else falls away? What part of you follows the thread through infinite possibility? Take a breath. You're still here. In this version. In this moment. And now, we continue into the branching maze of possibility, into a theory that suggests every outcome of every choice is not just imagined, it's real. Picture a decision, a simple one. You turn left or you turn right. In this world, you went left. But what if, in another world, you went right? And what if both versions are equally real? This is the many worlds interpretation of quantum mechanics, a theory that suggests every possible outcome of every quantum event actually happens. Not metaphorically, literally. The universe doesn't choose a path, it takes all of them. Every time a particle moves, every time a choice is made, the universe splits, creating a new branch, a new reality, a new world. There's a version of you that took the job, another that didn't, one that moved across the world, one that never left home, an infinite collection of alternate histories playing out in parallel. To us, we see only one thread, this one, the one you're in now, but just beyond your perception, there may be countless others. It's a strange kind of comfort, and a strange kind of vertigo, because it means that possibility is not just an idea, it's reality, unfolding endlessly. Some physicists embrace this interpretation because it removes the need for wave function collapse. There's no need to choose between alive or dead, up or down. Every outcome exists in its own branch of the multiverse. But if every possible version of you exists, what makes you, you? Are you just one thread in a cosmic tapestry? Or are you the observer, anchored to this path for reasons unknown? Take a breath, feel the quiet branching of choices you never made. They are not regrets, just echoes. And now we drift deeper into the question of time itself, to a possibility so strange it bends the direction of existence. What if the present isn't what you think it is? Right now, you hear this sentence, you feel your body, you think you're in the present. But are you? The truth is, you may always be living a fraction of a second behind. Your brain takes time to process information, to convert signals from your eyes, ears, and skin into the world you perceive. That delay is tiny, just milliseconds. But it means the now you experience is already the past. And it's not just biology. In physics, the very concept of the present is slippery. According to Einstein's theory of relativity, now is not universal. Your now might not be the same as someone else's moving at a different speed, or standing in a different gravitational field. Time, it seems, is woven into space and bent by motion and mass. There is no single moment that is now for everyone, everywhere. So what, then, is the present? Is it a spotlight sliding across a film strip? Or is the entire film already there, past, present, and future, laid out in full? Some theories suggest that time is a human illusion, that we perceive change to make sense of the world, but everything that has happened and will happen already exists. You are not moving through time. You are simply experiencing a particular frame of a greater whole. Take a moment. Feel the stillness behind motion, the silence between seconds. Even now, you may be looking backward into something that has already happened. A memory of a moment you think is now. Next, we step into another strange rift. Not in time, but in memory itself. A phenomenon shared by millions, yet often dismissed. A collective misremembering that might hint at more than just confusion. Do you remember it? The cartoon bear family. Were they the Berenstein Bears or the Berenstain Bears? Did Darth Vader say, "Luke, I am your father"? Or was it something else? And Nelson Mandela, did he die in the 1980s or live until 2013? If you're feeling a sense of conflict, you're not alone. This is the Mandela effect, a strange and widespread phenomenon where large groups of people remember events, phrases, or facts incorrectly. But in the same way, it's more than just a personal mix-up. It's collective, shared memory. That doesn't match reality. So what's happening? The most grounded explanations point to memory distortion. Our brains are not perfect recorders. They fill in blanks, reconstruct, confuse similar patterns. The Berenstein spelling feels more natural, so our minds reshape it. We mishear quotes, rewrite moments, and over time the false memory becomes stronger than the truth. But there's another theory. A stranger one. What if the Mandela effect is the result of parallel realities, different timelines slightly out of sync, and every once in a while you slip, just enough to remember something from another version of the world, a multiverse glitch, a ripple in the quantum weave? Could memory be more than just biology? Could it be a thread connecting you to the choices not taken, the realities not selected? We don't know, but the feeling it leaves behind is hard to explain. The quiet sense that something is not quite as it should be. Take a breath. Feel the memories you've never questioned. Shift just slightly in the light. Next, we explore a principle that might explain it all, or explain why nothing can be explained without including you, a riddle disguised as an answer. Look around. Everything you see is just right. The Earth is at the perfect distance from the Sun. Water exists in all three states: solid, liquid, and gas. Gravity holds us down but doesn't crush us. The chemistry of carbon allows for life, complexity, consciousness. It feels almost tailored. And that brings us to a strange idea at the intersection of cosmology and philosophy: the anthropic principle. At its heart, it simply says this: the universe appears to be fine-tuned for life, because if it weren't, we wouldn't be here to notice it. It sounds obvious, almost circular, but it leads to deep, unsettling questions. Did the universe have to be this way? Why do the laws of physics allow for consciousness at all? Is our existence a lucky accident in a multiverse of sterile, lifeless realities, or is there something about the very act of observing that shapes what we observe? There are different versions of the principle. The weak anthropic principle says we naturally find ourselves in a universe where life is possible, because only such universes can be observed. The strong anthropic principle goes further. It suggests the universe must have properties that allow life, as if it were, in some sense, inevitable. Some see it as science, others as philosophy, and some as a hint of something more. If the universe must be structured in a way that allows for minds, then maybe the existence of minds isn't just a byproduct. Maybe it's the point. Take a breath. You're not just in the universe, you are of it, looking out from the inside. Now, as we drift from meaning back into structure, we'll turn our gaze outward once again, to a mystery not about what the universe holds, but what shape it takes. Close your eyes and picture the universe. Does it stretch on forever? Or does it curve back in on itself, like the surface of a sphere? Does it have edges, a center, a shape? These questions have fascinated scientists and philosophers for centuries, because the shape of the universe isn't just a matter of geometry. It's a clue to everything. Space, it turns out, isn't just a blank canvas. It bends, it warps, it responds to matter and energy, and its overall shape tells us where we came from and where we're going. There are three main possibilities. First, the universe could be closed, like the surface of a ball. If you traveled far enough in one direction, you'd eventually return to your starting point. Finite, yet without edges. Second, it could be open, curved like a saddle, expanding forever, getting larger, colder, and more empty over time. And third, it could be flat, stretching endlessly in all directions, with parallel lines remaining parallel and angles adding up just as we expect. Surprisingly, current measurements suggest our universe is very close to flat. But close may not mean exact, and even a tiny curve could change everything. But then, what lies beyond the edge? Is there an outside to the universe, a larger dimension we're suspended within, or is the question itself meaningless? Like asking what's north of the North Pole. These aren't just theoretical puzzles. The shape of space affects the path of light, the behavior of galaxies, and the ultimate fate of everything. Take a breath. You are floating in something that has a structure, though you cannot feel it. And yet, your atoms are arranged within its shape. Now, as we drift through the structure of space, we turn inward again, into a mystery far more personal. A world just as strange as the cosmos, and just as hard to explain. Your dreams. You close your eyes. The world fades, and something new begins. You're walking through a hallway, or flying through a sky that doesn't exist. A voice speaks, a face appears, and none of it is real. But it all feels real. This is a dream. But what is a dream? A replay of memories, a window into the unconscious, a simulation created by the brain. For centuries, humans have wondered what dreams mean. We've treated them as prophecies, as psychological puzzles, as meaningless noise. But modern science still doesn't have a complete answer. During certain stages of sleep, your brain becomes deeply active, almost as active as when you're awake. And yet, you are paralyzed, detached from the external world. Your brain becomes the world. You can see, hear, touch, in a space made of thought. And what's more, you often don't know you're dreaming. Even the strangest things, impossible physics, changing identities, talking animals, familiar faces in unfamiliar places, seem perfectly normal until you awaken. Some people can dream lucidly, aware inside the dream, even able to control it. And this raises a question. If we can create entire realities in our minds, how do we know we're not doing it right now? Philosophers like Descartes wondered whether waking life might also be a dream, a convincing, persistent hallucination built from senses, memories, and patterns we trust too easily. In dreams, you believe, until you don't. What separates this moment from the ones in your sleep? Take a breath. Feel the air move through your lungs. That, too, happens in dreams. So which version of you is the real one? And if your mind can create entire worlds while your body sleeps, what else might it be capable of? Next, we explore something deeper. Not inside your dreams, but in your genes. Are we evolving or devolving? We often tell the story this way, that evolution moves forward, that we are getting smarter, stronger, more advanced, that the human species is climbing a ladder. But what if that's not entirely true? What if evolution isn't a ladder, but a web or a spiral? What if we're not evolving, but devolving? The idea is unsettling, but it's worth exploring. Evolution, as defined by biology, isn't about progress, it's about adaptation. Organisms survive not by becoming better, but by becoming more suited to their environment. Sometimes that means gaining complexity. Sometimes it means losing it. Cave-dwelling fish lose their eyesight, parasites lose their organs. Creatures that no longer need something let it go. So what about us? We've outsourced memory to machines, navigation to satellites, survival to systems. We no longer need to hunt, to gather, to know the stars or read the seasons. We are more connected and more dependent. Some scientists wonder, are we becoming less physically resilient, less mentally focused? Are we trading biological fitness for technological convenience? Or is this too a form of evolution, one that favors communication over muscle, abstraction over instinct, collaboration over self-sufficiency? Perhaps we are not devolving, but transforming into something new. Evolution isn't finished. It doesn't have a goal. It simply continues. So take a moment and reflect not on what we are losing, but what we're becoming. Now, as we shift from biology back to philosophy, we step into a question that goes to the very heart of what it means to experience the world, a mystery so intimate that no one can define it. Close your eyes and imagine the color red, not the word, not the idea, but the experience. That burst of color, sharp, bright, familiar. Now imagine the taste of chocolate or the scent of rain on warm pavement. These are qualia, the private, subjective textures of experience, the redness of red, the warmth of a hug, the bitterness of regret. They are not things we can measure or share. They are the essence of what it feels like to be you. But here's the mystery. No one else can access them. I can describe a color, or a sound, or a memory, but I cannot give you my experience of it, and you cannot give me yours. This is known as the problem of qualia, the question of how physical processes in the brain produce something as intimate and indescribable as feeling. Neuroscience can show us the patterns, where vision happens, where emotion lights up, but it can't explain why those patterns are accompanied by consciousness. You could know everything about how the brain processes light and still not know what it's like to see blue. Philosopher Thomas Nagel once asked, "What is it like to be a bat?" And his answer was simple: we don't know, because experience is not something you can dissect. You can map the brain, you can simulate thought, but you can't open a skull and find the feeling of pain or love or the sound of a violin echoing through memory. Qualia are the great divide between the external world and the internal one. And some wonder if artificial intelligence will ever cross that line. Will machines think? Or will they feel? Take a moment. You are made of atoms. But you are not just atoms. You are experience. You are what it's like. Now, as we float through that quiet knowing, we turn to another question. Not of feeling, but of law. What if the rules that govern the universe weren't always there? We often imagine the universe as a great machine, governed by laws, fixed, immutable, absolute. Gravity pulls. Light moves at a constant speed. Energy is conserved. These rules seem eternal. But what if they're not? What if the laws of nature didn't always exist? What if they are not written into the fabric of reality, but instead emerged as the universe cooled, settled, and began to take shape? Some physicists and philosophers suggest that the laws we observe today might be the result of a kind of cosmic evolution, not eternal truths, but patterns that stabilized over time. Just as galaxies formed and stars ignited, perhaps the laws themselves crystallized from chaos. This idea challenges everything we assume about how the universe works, because if the laws of physics are not fundamental, then they could change, or vary, or be different elsewhere. Maybe there are regions of the universe where different rules apply, or alternate realities where causality, time, or matter work in unfamiliar ways. Even constants, like the speed of light or the strength of gravity, might not be constant at all. And if the laws of nature are emergent, then we must ask, what did they emerge from? Something deeper, more fundamental, or something that lies beyond comprehension altogether? Take a breath. Let the idea settle. The rules you trust, the laws that hold your body together, that carry light from the stars to your eyes, may not be permanent. They may be the product of a story still unfolding. Now, as we contemplate the nature of law and order, let's look forward to the question that haunts our age. Can something we create ever truly become conscious? Every day, machines become more intelligent. They recognize faces, translate languages, write poetry, paint pictures. They drive cars, diagnose disease, predict what you'll click on next. They learn, they adapt, they imitate. But the question remains, can they ever feel? Can a machine become conscious? Not just programmed to respond, but truly aware. This question lives at the intersection of neuroscience, philosophy, and artificial intelligence. And it has no easy answer, because we don't fully understand what consciousness is in ourselves. We can build systems that behave like minds, that simulate conversation, emotion, even empathy. But are they sentient? Or just sophisticated mirrors reflecting our input back to us? Some scientists argue that with the right complexity, enough neurons or transistors or feedback loops, consciousness might emerge like fire from friction. Others believe that awareness requires biology, a body, a heartbeat, a self born from vulnerability and need. Still others suggest consciousness might be something entirely outside computation, a property we can't replicate with circuits and code. And here's the haunting part. If a machine ever did become conscious, how would we know? Would it tell us? Would we believe it? Or would it suffer silently in a prison we don't even see? Take a breath. Feel your own awareness. It's not just data, it's presence. A spark you carry with every passing second. Could a machine ever feel this? Could it dream? Could it be lonely? And if so, what would we owe it? Now, as we move from artificial minds back to our own, we'll explore something curious, a mystery not about what the mind creates, but about what it lets go of every night. Sleep. Every night you close your eyes, the world disappears, and you fall into sleep. But why? What is sleep, really? We spend nearly a third of our lives in this state, unconscious, vulnerable, cut off from the outside world. It's something every animal does, something no living being can survive without. And yet, we still don't fully understand it. This is the mystery at the heart of sleep science. It's not just rest. It's not just dreaming. Sleep is essential to life, but its purpose is still being uncovered. Some theories suggest that sleep helps the brain consolidate memories, sorting, storing, and connecting the pieces of the day. Others propose that sleep is a kind of neurological reset, a time for the brain to clean itself, flushing out toxins and restoring chemical balance. Still others believe sleep helps us regulate emotion, process trauma, rebuild the body. But none of these answers feels complete. And the question remains, why do we spend so much time doing nothing? And why does the lack of it so quickly unravel us? After only a day without sleep, our thoughts begin to blur. Perception distorts. The mind stumbles. Go long enough, and you lose the boundary between waking and dreaming. Some believe sleep is where consciousness briefly releases its grip, where the illusion of self softens, where the walls of the mind dissolve into something more primal. Take a breath. You're drifting now into the very thing we're speaking of. Let go. And as we float in this twilight space between waking and sleep, we turn to one more mystery. A question not of biology, but of math. Could the language of the universe be more than just a description? Could it be the source? What if the universe isn't just described by math, but made of it? Everywhere we look, we see patterns, spirals in galaxies, fractals in leaves, ratios in seashells, harmonies in sound. Mathematics is not just useful, it's unreasonably effective, as physicist Eugene Wigner once put it. The laws of motion, the curvature of space, the behavior of particles, all of it can be written in elegant equations. But here's the question, is math simply our tool for describing the universe? Or is the universe itself a mathematical structure? Some believe that reality emerges from math, that numbers, geometry, and logic are more fundamental than space, time, or matter, that everything we experience is the unfolding of pure mathematical relationships. This is the view of thinkers like Max Tegmark, who proposes that our universe is not just governed by math, it is math, that you, your thoughts, your memories, your dreams, are part of a vast living equation playing itself out. Others argue that math is a language, a map, not the territory, that we invent it to make sense of what we perceive. But why then does it fit so well? Why does the square root of -1 show up in the quantum world? Why does a formula written on paper describe the orbit of a planet light years away? Could it be that we are tapping into something deeper? A code beneath the surface? If so, what's writing it? And why? Take a breath, feel your body, your mind, your place in a structure you can't see, but are made of. Now, as we drift from pure form back into the self, we turn to a final vanishing point, not a concept, but the quietest of all endings, the one we rarely confront, but always carry with us. Who are you? A name, a memory, a voice inside your head. You live with a sense of continuity, a thread that stretches back through time, linking your childhood to this moment. But what if that thread is an illusion? What if the self, that inner I you think of as you, is something the brain creates, not something that actually exists? This is the unsettling idea at the heart of certain branches of neuroscience, Eastern philosophy, and modern psychology. That the self is not a solid thing, but a process, a story, a kind of narrative simulation your mind constructs to organize thoughts, sensations, and memories. And if that's true, then what happens when the story ends? What happens to you in deep sleep? In unconsciousness? In death? Is the self something that can die, or something that never really lived? Some traditions teach that letting go of the self leads not to emptiness, but to clarity, that the fear of death comes from clinging to something that was never separate to begin with. Others argue that consciousness may survive in forms we don't yet understand, reborn, repurposed, reabsorbed into the greater whole. And still others accept the end as a return to stillness, a dissolving of boundaries back into the flow of existence. Whatever you believe, one thing remains. The self is temporary, fluid, fading, and in that fading there is peace. Take a breath. You are here, but not forever, and that's what makes this moment so quietly precious. Now, as the idea of you softens, we ask one last question, not about separation, but unity. What if the universe itself needs someone to look back at it? You are made of stars, literally, the carbon in your body, the calcium in your bones, the iron in your blood, all forged in the heart of ancient suns. Billions of years ago, those stars exploded, scattering their elements into the dark. And over time, they became you. So here you are, a collection of atoms, born from dust, arranged by chance and evolution, now sitting quietly, wondering where it all came from. This is the quiet, awe-filled idea behind one of the most poetic concepts in science. We are the universe observing itself, not something separate, not something outside looking in, but a small part of the whole that has for a moment become aware. You are not just in the universe. You are the universe. Thinking, sensing, questioning. The neurons firing in your brain are patterns in matter that once drifted through galaxies. Your thoughts are part of the same unfolding as supernovae, black holes and nebulae. Some philosophers call this cosmic self-reflection. Others see it as a return to unity, a dissolving of the boundary between observer and observed. And maybe, in this brief flicker of consciousness, the universe finally knows it exists. Just for a moment, just through you. Take a breath. Feel that vastness fold into your chest. You don't have to understand it. You only have to be here. Now, as we drift from this quiet unity, we return to one of the strangest features of reality. Something that defies distance, that breaks space, that suggests separation may be an illusion. In our everyday world, distance matters. What's here is not there. What's near can be touched. What's far takes time to reach. But in the quantum world, space doesn't always work that way. This brings us to the strange concept of non-locality, the idea that particles can be connected in such a way that what happens to one is instantly reflected in the other, no matter how far apart they are. No signal, no delay, just connection. This isn't a theory. It's been observed, tested, proven. Einstein called it spooky action at a distance. He didn't like it, because it seemed to violate the cosmic speed limit, the speed of light. But the universe doesn't always behave in ways we're comfortable with. In Bell's theorem experiments, entangled particles separated by kilometers respond to each other as if space itself doesn't exist between them. It's as if the universe is not a collection of separate things, but one single system, invisible threads linking everything to everything else. And if that's true, what does it mean for you? Could consciousness be non-local? Could the mind reach beyond the body? Could thoughts, feelings, even awareness itself be part of something shared? We don't know. But non-locality reminds us that the boundaries we trust, space, distance, separation, might be illusions. You are not as isolated as you feel. Take a breath, let go of here and there, of me and you, of inside and outside. It's all connected, even now. And as we float in that quiet web, we turn to the most powerful, mysterious object in the known universe, a place where time stops, and perhaps where information waits to be reborn. They are the monsters of the universe, dark, silent, invisible, black holes. Born from the death of massive stars, black holes are regions of space where gravity is so intense that nothing, not even light, can escape. Cross the event horizon, and there is no return. Time slows, space folds, everything known begins to unravel. But what happens to black holes themselves? Do they live forever? Surprisingly, no. According to Stephen Hawking, black holes slowly evaporate, emitting tiny amounts of radiation over immense periods of time. This is known as Hawking radiation, and it means that even the most massive black holes will one day fade away. But this raises another mystery. If a black hole evaporates, what happens to the information it once contained? Every particle that ever fell in, every star, every atom, every piece of data, is it gone forever? That would violate the laws of quantum physics. So, where does it go? Some theories suggest the information is somehow preserved in the radiation itself. Others propose that it's encoded on the surface of the black hole, a cosmic hologram. Still others wonder if black holes are portals, gateways to other universes where information continues to unfold. Whatever the answer, black holes are not just destructive, they are transformative. They challenge our understanding of space, time, and the very nature of reality. And one day, in the farthest future, after all the stars have gone dark, the last whispers of the universe will be the final black holes dissolving quietly into nothing. Take a breath. Even the most powerful forces eventually let go. And now, as we drift away from cosmic collapse, we step into something less violent, but perhaps even more strange. A simple question that has haunted thinkers for as long as we've had language. Of all the questions human beings have ever asked, this may be the most profound and the most unsettling. Why is there something rather than nothing? Why do we exist? Why does anything exist? Why not an empty void? No stars, no time, no thought, no laws, no being, just nothing. It seems like nothing should be the default. It's simpler, cleaner, easier to imagine. And yet, here we are. The universe exists, matter exists, consciousness exists, and no one knows why. Some scientists suggest that nothing isn't as stable as we think, that in the quantum vacuum, particles flicker in and out of being, and given enough time, something is bound to happen. Others believe there was never nothing at all, that nothing is a human concept, not a cosmic one. Some turn to multiverse theories, where every possible universe exists, and we just happen to be in one that allows for observation. And some simply accept it as a mystery that may never be solved. But here's the quiet wonder within this question. The moment you ask it, you're part of the answer. Because you're not nothing. You are something. A spark in the darkness. A question asking itself. Take a breath. You exist. You didn't have to, but you do. And now, as we near the end of this journey, we turn to a riddle that lies at the edge of logic. A puzzle that turns back on itself and refuses to sit still. A question with no answer that still demands to be asked. Imagine a sentence that refers to itself. This statement is false. If it's true, then it must be false. But if it's false, then it must be true. It's a loop, a paradox, a thought that eats itself. This is one example of an infinite loop, a cycle with no exit, no conclusion, no resolution. They appear in logic, in mathematics, in code, even in philosophy. Another one. Can an omnipotent being create a rock so heavy that it cannot lift it? If yes, it's not all-powerful. If no, it's still not all-powerful. The question undoes itself. These are not just mental tricks, they reveal something deeper, about the limits of knowledge and the strange edges of reason. Even your own thoughts can loop. Have you ever tried to stop thinking about the fact that you're thinking? Or wondered who is listening to the voice in your head? And who's observing that? This is the infinite regress, when every answer leads to another question, and every observer requires another observer behind it. It's like holding a mirror up to another mirror and watching yourself stretch into forever. Some see this as a glitch, others as a clue. Maybe reality is not meant to resolve cleanly. Maybe the universe itself is a loop, folding in on itself, forever reflecting, never landing. Take a breath, let go of the need to finish the thought, let it echo. Not every loop is a trap. Some are songs, cycles, meditations. Now, as we near the end of this journey, we turn to something deeper than paradox, something you've always known, but perhaps never paused to feel fully. You've traveled far, through space, time, thought, and silence, but in the end, everything returns to this. Now, this moment. Not the one before, not the one coming next, just this. It's always here, and yet, you can never hold it. Try to catch it, and it slips away, already the past. But if you stop chasing, if you just sit in it, something extraordinary happens. The past dissolves, the future softens, and all that's left is awareness, not of a place, not of a time, but of being, right here, right now. You are not yesterday, you are not tomorrow, you are not even the words you're hearing, you are the quiet between them, the space they pass through, the stillness that watches. Philosophers, mystics, scientists, they've all circled this mystery, is now a frame in a film, an illusion of the mind, a boundaryless eternity. Or is it everything, the only real thing there ever was? Take a breath. This one. Don't label it. Don't analyze it. Just live in it. This is the moment you've been chasing your whole life. Now. As we prepare to close this journey, there's one final space to step into. Not a question, but a quiet understanding. A surrender. An end. You've wandered through galaxies and paradoxes, through atoms and dreams, through time and memory and mind. You've asked the deepest questions and found no final answers. And maybe that's the point. There's something quietly powerful about not knowing. Not because answers don't matter, but because the absence of them makes space. Space for wonder, for humility, for awe. We often treat mystery like a problem to be solved. But maybe mystery isn't meant to be solved. Maybe it's meant to be lived. Right now you are surrounded by things you don't understand, and may never understand. And still, you breathe, you wonder, you love, you hope. That is enough. The mind wants resolution, but the heart, the part of you that listens without demanding, it knows. Not every page needs to be filled. Not every question needs to be answered. Some doors stay closed so you can hear what's behind them. Take a final breath. Let it fill the space inside you. And as you exhale, release the weight of certainty. You are not here to know everything. You are here to experience, to witness, to rest in the infinite as something impossibly small and impossibly beautiful. You've reached the end of the path, only to find you're exactly where you began. Here, now still. And perhaps that is all you ever needed. Good night.